The Earth is very flat.
What's going on, everybody? It is Monday, August 16th, 2021, and I have the power back on in my house. Thank you. I don't know who I should thank. Thanks, DTE. Thanks, Thomas Edison. I don't know. But the power's back on nonetheless. Missed you guys. Yeah, I did, actually. It wasn't that enjoyable of a break. I was eating out of bags most of the time. We cooked up what meat we could, so we didn't have to throw it away. And yeah, I was like camping in our house, charging everything with the car. Of course, I couldn't be without electronics. 2 bars of service. Yeah, it was horrible. It was really horrible. First world problems, but I've changed my mind about living off the grid, and I no longer am interested in that concept. So that's what it is. Anyway, welcome to the show. This is Brandon's show. I'm Brandon. And this is a show dedicated to an unapologetic and unwavering ground-up exploration of the world. So that's our first goal, right? And that's what we're going to continue doing. I'm very excited about the future. I hope you guys will stick around and help me help each other kind of move things forward, because I have a little feeling that things are going to progress very rapidly from here on out. And I can't wait to share why with you guys. Unfortunately, that won't be today, but you'll have to stay tuned to see what I'm talking about. Anyway, sounds good. Thank you very much. Yes, Adam Meekin did make the intro. Shout out Adam Meekin. Thank you very much. And yeah, steal the music. I do get a copyright notice every time I use it, but I don't give a shit. They can take the 12 cents and be happy with it if that's what they want. So anyway, we got some people in Discord. So let's go see what's going on. Say hello.
The difference between 2 and 1 is greater than 1 and however many decimals you want. That's the key difference here. We can talk about the power that would take, or the time that it would take to reach these pressures, and then the structural integrity. But when we're talking about the difference between pressures, there's a greater difference between that 2 and 1. There's a greater difference between me and the top of a 500-foot tower than there is between when we're talking about 1 torr and then this extreme negative 17.
4 minus 1 is going to be higher than 2 minus any number that's lower than 2. 3 minus 1 is going to be higher than any 1 minus any number that's lower than 1.
Sure.
What is the argument that's happening here? It seems like you're just stating a thing about how numbers work in math.
Right. So what the typical response is, and especially if you watch the numpty clip of mine, what the typical response is that it's a magnitude greater thing. It's a vastly different thing. These differences between 1 and 10 to the negative 17 is, millions of magnitudes greater. It's not that much when we're talking about pressure.
Yeah, you're having tons of less gas molecules. Each decimal place is a magnitude.
Yes, you're having a lot less. There we go. See, everyone spirals as soon as I say that. So yes, you're right. The magnitude argument is correct, but we don't give a shit about magnitudes when we're talking about pressure. There's a bigger pressure difference between me at sea level and 500-foot tower. There's a bigger pressure differential there than there is between 1 and any decimal value you want.
What's the highest pressure value ever measured?
No. How did you get that measurement?
Math. Oh, how did you get the measurement? I got to 20 torr. I've personally done that.
Yeah, no. What device did you measure that with?
I measured mine with inches mercury gauge.
Oh, okay.
Hey,
so like a barometer.
No, an inches mercury gauge.
A thermometer then. Biodual, did you watch my video about Biodual, did you watch my video about the the common sense approach to gas pressure on flat Earth test?
No.
Okay. All right. So you need to start checking these out so you'll know what the hell we're talking about. Usually when I bring it up, we talk about. But anyway, to go on where you're going is so I did this. So I compared the gas pressure to like a syringe the size of a car or something, a giant syringe with a big plunger with a handle. So we're creating a vacuum inside of the syringe with a big ass handle that I'm pulling on to pull the syringe back to create a more powerful vacuum. Okay, so then I compared it to like me getting the strongest vacuum I could, getting it down to like 0.5 psi or something. Then I tie a rope and a horse to the plunger, and I swat the horse on its ass, and I start pulling a vacuum. He starts pulling a stronger vacuum, getting more and more of the air out. Then I tie like 5 horses. So what they were trying to say on Jim Panda's channel or his Discord server, which you get muted every time you fucking respond. But besides that, when you can talk, the answer I got is everybody's saying, including McToon on his channel, they're all saying that like 10 to the negative 17 torr is barely different than 10 to the negative 1 torr. They're saying that it's barely different. When I was trying to say you take these pumps, like you need stronger pumps to get bigger, stronger vacuum. Like if you take a 5 horsepower pump.
Do you know why?
Yeah, go ahead.
It's because of the outside pressure. If you have, let's just say 2 sets of chambers, and one chamber is atmospheric pressure, and inside that chamber is another chamber, and you're pulling a vacuum, using the same pump, you're going to be able to get to a certain spot in 30 minutes, whatever. If you have another chamber in which it's at, let's just say 2 psi, rather than atmospheric pressure, it's at 2 psi, and you have a vacuum chamber within that chamber, and then you want to pull, you want to use the same type of pump with the same pumping power, you're going to get to be able to go to a lower pressure because it's the outside pressure that's affecting it, not the vacuum itself.
I'm okay with that, but also increasing the size of the vacuum, the area.
Sure, the surface area, yes, because there's more surface for more pressure. Yeah, so there's, instead of, let's just say 10 square inches of a cube that's being pressed on, now it's 30 square inches of that same pressure over more surface. So yes, it will take more work to do the same thing. Sure.
So let me ask a question. Do you personally believe that let's say 10 psi inside the limb, or 5 or 10 psi, do you believe that a few layers of foil, or even the thickness of a Pepsi can or a Coke can, do you believe that could withstand? Do you believe the pressure inside of that limb could withstand vacuum of 10 to the negative 17 torr, or anything even close to it?
The exact way that you described it, my intuitiveness says no, of course. But again, the exact way that you described it, as well as my intuiting, yes, I don't think that would be possible now.
Hey, what's up, guys? What's going on? We're live. Brandon? How you doing? Good to be back. Man,
hey, Brian, I missed you, man.
I missed you too, Brian.
I can't handle the withdrawals, bro.
I was thinking about you all weekend, buddy.
I was trying to put out some videos, man, for you, man, to watch. And so what happened, man? You was out of power and shit up there?
Yeah, evidently we've got a power system here that electrical grid that is really susceptible to any wind of any kind whatsoever. We've got a lot of tall trees, I guess, around the lines. So I don't know if that has anything to do with it, but it was ridiculous, man.
I have 7 solar panels, man, for a situation like that, but I could have never live streamed or nothing like that. But I'd have a little emergency power. Do you have anything like that for
no
your refrigerator or something? That sucks.
Yeah, totally. Yeah, it was pretty rough, but I made it through. Couldn't do the show, obviously. I was working off of 2 bars on my cell phone. I guess I must have knocked out a tower or something, or a repeater, or something that relies on electricity. So I was like, oh, it was rough.
You had to ration out the power on your phone. Well, look, man, I'm working on this, still working part-time on this, running the generator off the HHO gas. So look, as soon as I get it figured out, man, you're the first person I'll send it to, man.
Sweet. Looking forward to seeing that. We got a lot of people in here tonight. It's good to see a good crowd to start off. Let me just tell the audience, everyone who's in here, we've got Chemo, Angel of Attack, Autodidactic, Biodual, Brian Leakey, Chad, Chikey, Conrad, D-Mock, Drink the Kool-Aid, Extremistus, Face One, Farming Ganja, Effie Water, Geo, J711, Jeremy, Carnivore, Left Lane, Matrix Media, J, Rob on the level, Keen, Stu Unger, The Real Bob Dole, and Witless Protection. Hello, everyone.
Hey, what's up? Hey, Spurs, I wonder if if they mute you Spurs chemo every time you say something they don't like. Well, here's the definition of irony, or not even the definition, but some irony is they'd be talking about going to Nathan Oakley's show over there on Jim Panda's, how you can't talk, you mutes, all that shit, and then you speak up and you get fucking muted. It's a fucking joke, dude. They're bitching about Nathan, and the first thing you say they don't like, you get fucking muted. I don't know that it's Jim doing the muting, but somebody over there. If you just say something he don't like, and you're quickly silent.
Did anyone mute you?
I almost never get muted.
Brian, by unmuting when I can.
It's actually chemo muting, Brian. Nice cover, chemo.
We were giving him hell today.
Yeah, that was good stuff, man. Last couple of days, I spent quite a bit of time in there over the weekend.
Brandon,
I'll give that to BioDuel. This BioDuel gave a common sense answer. Like, he's like, just from thinking about it, no, it doesn't seem like it'd work. At least he's honest and shit. It's really hard to get any honesty over there. And when you say something they can't rebuke, they start attacking. I mean, they start pouring on the personal attacks and just trying to discredit me. I'm like, don't worry about me. Discredit arguments.
Brian, I asked you a simple a question which I still didn't get an answer to.
That's because I was muted, Chikey.
No, the conversation derailed, but I can ask it again. If you have a syringe with diameter of 1/2 an inch, what would be the maximum force you need to pull it?
Okay, now let me give you the answer. Listen this time, Chikey. Listen to me this time, Chikey.
Zero vacuum.
Okay, let me give you an answer and listen to me this time. Okay, if I had a plunger that was infinitely strong, I could never reach zero. I could pull harder and harder. I could hook 5 horses up. Listen, I could hook 5 horses up to that plunger. I could hook 10 horses. I could hook 1,000,000 horses up to that plunger, pulling, and I could never get to zero. It's exponential.
Okay. You can't never get to zero, but why do you need all these horses? Because all you need is about 2.5 pounds to pull this plunger that I just told you. So it doesn't matter you never reach zero, but you never need more than 2.5 pounds.
Hey Brian, can you hey Brian, sorry to interrupt. Your mic, can you switch it around or whatever you do sometimes? Because
I hope that's a little bit better, man. I hope that's better.
Sounds better.
But Chikey, I definitely understand what Chikey's saying, but I'm just trying to bring a common sense argument. Of course they don't have a syringe the size of a car, and you're bringing it back down to size. But I'm just saying, like, a vacuum, you could never reach maximum pressure either, Chikey. You could say, hey, the highest pressure I've ever reached is such and such, and you could say how you measured it and all that, or you could say the strongest vacuum I've ever reached. The vacuum is just the opposite of the pressure. And you could never reach zero, just like you could never reach the other end of the spectrum. That's why it's exponential. And when they were describing it to me, so Kosho in his explanation said that 1 psi is half the strength of 2 psi. So then I go to ask him, so is 0.5 psi 4 times stronger than 2 psi? And he's like, yeah. So then that means 0.00, you see what I'm saying, psi, it's exponential. In other words, you'll never reach zero. You'll just keep getting stronger and stronger vacuum. They don't like acknowledging that, though.
No, it will not get stronger. It will converge to a finite number.
You guys are talking about the Tor scale. I don't really understand any of that. We should have a basic description then. Let's bring this back to flat Earth. What does the Tor scale have to do with the shape of the Earth? Just out of curiosity.
Doesn't.
No.
Okay, it has to do with. To me, it has so much to do with flat Earth. Okay, first off, they took the picture, the only ever claimed photograph of the entire planet from that region, okay, with the astronauts in it. Alan Bean, God rest his soul, not trying to dog him out, but I'm just trying to point out his comment where he said they had to be careful next to the edges of the limb because it was the thickness of 2 sheets of aluminum foil. We're told by the globe model that it gets down as low as 10 to the negative 17 torr, which is still a positive pressure, but it's so many zeros. That's 17 zeros of decimals, and they try and use negative. They try and use addition and subtraction to explain the pressure, and that's either ignorance or dishonesty.
10 to the negative 17 torr has a massively minute amount of gas molecules in every cubic meter of space.
Correct.
Massively
But my whole
minute.
point was
When
to
you compare it to,
disregard
like,
the
10 to the
numbers.
It's either massive or minute. Can be both.
What did I
The
say?
whole point is the power it takes to achieve a vacuum like that is a lot.
It's relatively empty, very empty.
Yes, and if you had like 10 to the negative 1 torr, you'd have way more gas molecules in the cubic square meter. Massively different amount. Yeah.
Well,
Where
between those two amounts, sure, massively. But when we compare that,
That's where you fucked up in that numpty clip.
Yeah, hold on, Jeremy. But when you talk about that difference, there's less of a difference there than there is between I'm pretty sure sea level and the roof of my house. That difference.
Yeah, that's a good example.
Yeah, but when you have those two next to each other, isn't it really come into play when you have them next to each other, like this Byford dolphin accident that I'm showing on my screen? Have you ever heard of this? I think we might have talked about it before. But it was this horrible diving bell accident where somebody fucked up and opened the safety latch of the diving bell to get into this underwater chamber, and it violently dismembered all of the people and drove them through like this 32-inch hole. It was ridiculously disgusting. Pictures on the internet. I do not suggest that you look at it, but so that pressure differential has a lot of power. Are we saying that it doesn't have that same power when you go down closer to vacuum level, or
it's just a difference? And the example that I gave to Brian when we were talking about the 2 sets of chambers, if you had that diving bell situation where the outside pressure was a lot less and you open that hatch, that destruction that occurred would be a lot less. Probably still destruction, but would be a lot less. It's just the difference in pressure and when you open them to each other. That's all.
Well, allow me to give an example. Okay, now I've seen. Okay, they say that the tin can or the Pepsi can, whatever, can it's like at about 15 psi, or no, it's at about 60 psi. So it's withstanding 40 pounds of differential. Now, I've seen a Mountain Dew. That's bullshit. You've been lied to. I've seen a Mountain Dew can inside of a vacuum chamber where they had a bigger pump and they started evacuating air, and the son of a bitch exploded with only a almost 14.7 psi differential. So what you've been taught is a lie. It is demonstrable.
Brian, you just said it yourself.
I asked that you accept it, bro, and accept what I just said, because I know you.
That's exactly what we're saying, Brian. But you just said that the can, without verifying your values, the can is exerting 60 psi on the inside, and then what you're saying is they removed the 14 psi on the outside. You're increasing that pressure differential. So before it was a difference of 60 minus 14 for simplicity, whole numbers. So that's 46. So that pressure differential was 46 psi. When you remove that 14 psi, for simplicity's sake, it's at 0. That pressure differential is now 60.
No,
okay, that makes sense. But my point is the more power you put into that vacuum, the stronger the son of a bitch gets.
You're not doing that. You're just increasing the pressure differential, though. So you're not. The vacuum doesn't have power. It'd be the same thing. It'd be the same differential if you started at 28 and brought it to 14, as you did.
By you saying it doesn't have power, though. Bodu, by you saying it doesn't have power is wrong, bro. If you can't pick up a car with a differential of about 10 psi, you can pick up a car with a vacuum of about 12 psi. You know what I'm saying?
You're talking about the differential.
Listen, you can show the power of vacuums, like Brandon just said. The differential it does crazy things. A vacuum is
I agree.
very strong.
The differential does, but that has nothing to do with the absolute vacuum. The vacuum is good because it's the baseline versus our 14 psi. But if we existed within 50 psi and we brought it down to 14, that's a bigger pressure differential than 14 to 0. That's all it is the differential. It's not the absolute value of what it is.
Bro, you're
Zero is
talking about the
arbitrary.
differential from outside the vacuum. I'm not, bro. I'm talking about from inside the vacuum. Look, like if you put a balloon inside the vacuum, the pressure outside the vacuum chamber is meaningless. Okay? I mean, it might not be meaningless, but look, the pressure inside of that balloon is what starts to expand. Okay? So if you have
because it has less things pressing on it outside of it.
So if you have 0.5 psi in that balloon and you start evacuate, say you have a strong mylar, it only gets so big for it explodes. And it's like 10-layer stick, so it's strong. If you keep pumping more and more air out of there, no matter how strong it is, you can make a powerful enough vacuum to rip that some bitch open.
That's not what
you're talking about. The differential from the outside pressure. I'm not talking about that. I'm talking about inside.
Right. That is what we're talking about. That is what we're talking about. When you're talking about the balloon with pressure on the outside, some type of atmospheric pressure, you're talking about the gas on the inside of the balloon pushing out, and then you're also talking about the gas outside of the balloon pushing in on it. There's an equilibrium that's met, and then there's structural integrity. When you remove the outside pressure, you're removing the thing resisting the inside pressure. So the inside pressure has nothing resisting it, so it's going to keep expanding until the structural integrity of the balloon makes it pop. It's not the vacuum doing it; it's a pressure differential. It's that simple.
And all right, I've got a question about this. You know, when we talk about the Earth and the Earth being inside of it's surrounded by a low pressure system. Let's say that a vacuum, really, right? We know it's not a perfect vacuum. Yeah. Okay, so yeah, I guess there's a gradual from 14.7 up to whatever it gets down to. We'll just say 0 for the sake of conversation. Okay. Pressure, but on a huge scale, if I'm looking at the Earth like it's just a little marble or something, there's not that much space. What? I can't wrap my head around. I can't make those two things make sense. That we have this pressure and it's surrounded by low pressure, but for some reason it doesn't do what it always does in any other circumstance that I'm aware of, and expand to fill that low pressure.
Brandon,
and I'm told it's because of this gradient, but I don't know why that would make a difference.
Your diving bell example is a great example of what happens when the pressures are 46.5 times greater than what we're talking about at the difference from outer space, vacuum, and Earth atmosphere.
Very good. Very good. Exponentially. The way he just described it, 46 times more powerful. Right. So it's exponential. So when we start reaching the low tours, it's way more powerful of a vacuum.
It's not exponential, Brian.
Brian. No. At the depth that diving bell was at, it was at 46.5 torr worth of pressure.
Okay, so that's a huge difference is what you're saying. That's why we saw that violent expulsion.
Right.
Because 46 times. So, okay. Nonetheless, the higher pressure went to the lower pressure. Why doesn't it in the Earth? And I know what you're going to say. You're going to say gravity, but gravity isn't strong enough on Earth to make that happen anywhere, is it?
Gravity is. I don't know. It just happened in the bell.
Well, the bell is an extreme case.
Yeah, gravity's there. Gravity's supposed to be strongest at the surface, but it can't keep the gas down at the surface. But it's supposed to be.
Well, it does, Jeremy.
That's why for every 30
feet, it doesn't. It goes up. If it does, why does it go up?
Because it's a dynamic system in which energy is being added, forces are acting on everything. Gravity is just one of those things. That's why we have an abundant amount of gas at the surface. And we have a low amount of gas. We have lower amounts of gas as you increase in elevation.
Why doesn't it pull the molecules that are furthest away? You know, our atmosphere expands. I think they're saying hundreds of thousands of miles. Why doesn't it pull that furthest away. Let's forget about the gradient.
It still does, but it's going to have less of an effect.
Okay, then if it
What
pulls that
pulls?
away, then it's going to pull the next layer off, right?
Right, and it's going to kind of stack on top of each other. Sure.
But it's got endless space to expand into, so it's not going to stop until it equalizes the pressure, right?
Until it, what do you mean equalize?
Until the pressure equalizes, which it won't, I guess. Those molecules, until they fill this nothingness that we're supposed to be in. So I guess they just keep expanding forever from high to low pressure, right?
There's a number of forces that are acting on it, though. That's what it is. I would call what we exist in with the globe model and a gradient atmosphere. I would call that equalized, because we have a gradient atmosphere. If it were not equalized, we'd have crazy fucking pressures. I mean, I guess you could call wind and storm systems, but again, you're adding influences. No one does. But you're adding influences.
I showed a gradient, dude. I showed a gradient inside containment. And everybody's like, what about the gradient? Listen, I have showed for the 100th fucking time, excuse my language, I have showed a gradient within 60 feet inside of containment. Y'all have never, ever showed pressure without a container because it's not possible, much less a gradient.
Blue did with PVC pipe from his ground level to the roof.
With a container, okay? I used a PVC pipe too.
It was open, Brian.
Yeah, your pressure gradient is a bunk.
So a pipe is not a container.
Because you showed a horizontal pressure gradient, never to be seen on Earth.
Shout out Rob Keen, $5. This is not for Jose or Ranty. Appreciate that. Thank you, Rob. Yeah, so why don't you tell us what you did, this pressure gradient? Well, before you do that, I guess the question that bothers me is there any type of experiment we can do that would simulate this situation? Like, I don't know, get a globe inside a vacuum and somehow suck a bunch of gas molecules to the sphere and watch it that way. Sit inside of a vacuum.
And then rotate it and watch the top layer of gas spin, all the gas spin with in lockstep with the surface of the globe. Yeah, that'd be a good one.
There's a gift someone provides for that, Jeremy. But as far as your thing, Brandon, on Earth, probably not, just because of Earth's gravity. But what I've been trying to think of is trying to spin a long tube and have different gauges at different parts of it, and then introduce centrifugal force, and then trying to show a pressure differential with an open container at different levels of it, however close or far from the source of the force. I might be doing that one day.
So how would you do that? You put a centrifuge inside of a vacuum chamber with some gas or something?
So I wouldn't do a vacuum. I mean, that could be it at some point, but the idea that I have is a bigger Lazy Susan, let's just say a 6-foot tube, or even my tube that I have now, 3 foot, and then every 6 inches I have a gauge on it, and then just introduce centrifugal force and try to get real-time data from that. And then what it would be is a force would be causing a gradient, essentially.
It's all in containment, bro. It's all in containment. What did Chucky say? Every time I go to talk about my container, I get a scam likely call. It cuts me off. What did Chucky say about my pressure inside a container, my gradient inside a container?
I said you show the gradient, horizontal gradient, which we never observe on Earth. It's not possible to have on Earth.
What are you talking about, Chucky? The pipe.
The pipe was sitting on the ground. Both ends on the ground. Why would there be pressure gradient there?
Okay, what was different? Okay, why was there only pressure on one
Your
side?
Your balloons were different. I don't know what was different. You never measured pressure.
Yes, I showed a balloon on one side.
Two different balloons.
See, his brain will not let him accept this. I had one side of the 60-foot long pipe, the last 10 foot, in boiling water. I had the other side in ice water. The side in the boiling water blew up the balloon, okay? I didn't need no fancy gauges or mercury or anything. I just put a simple balloon to cap it off, to cap the container off, okay?
So
now, why did the balloon on the pressure side blow up, Chikey?
I'll tell you why. because it's rubber, and when you heat it up, it's more flexible, and when you cool it down, it's less flexible. I don't know, Brian. That's not an experiment. That didn't show pressure gradient.
What's the name of the video, Brian? I'm trying to bring it up so people at least know what we're talking about. But,
Tyke's being dishonest.
yeah, but a lot of people who are watching may not know what we're talking about.
Pressure gradient demonstration.
I'm gonna post it in general for you, Brandon.
Okay.
Is it pressure gradient demonstration?
Oh yeah, there
Yeah,
it is.
yeah, without any
Right,
fancy
it is.
gauges, just simple
There you
balloons.
go.
Oh, simple balloon.
But bio, that experiment sounds good, the one that you described, but it doesn't show that pressure gradient inside of a low pressure system, right? What would that prove it, or what would that
It would be an open
falsify
container.
or support?
It would be an open container with a force that we wouldn't argue about or debate about, causing a gradient. So it would be what I would expect to see is the atmospheric pressure that we exist around would exist around this open container, but because we have this force here, the top of that container should be a lower pressure. There should be a difference between that and the pressure on the outside, despite this being an open container, showing a force can act as the boundary, such as a closed boundary would, such as like a dome, like, oh no, all the gas has to go somewhere because you have to have a physical dome or container. What it would be showing is just, no, we can have it open. We just need a force that would prevent it from escaping.
Oh, it seems like an interesting experiment. So I get it. Brian, so what are you doing here? You got a couple of things outside. What are these? You there, Brian?
Yeah, sorry about that. It's I have about 60 foot of PVC just glued together, and I just wrapped it around to where each end is right next to each other on the flat ground. And then I have 2 sections of gutter that came off of a house, the gutter that drain, but to catch the rainwater. So the last about, I'm gonna say 8 to 10 foot, about 8 foot of each end I put, because we know that temperature and pressure are joined at the hip. That's in all the gas laws, and that's why the pressure goes down up there. There's gas up there. It's just cold as shit, so it's not gonna show. It's just gonna be, I don't know. It's you know what I'm saying? But the whole point is at each end I put one end in boiling water of the 60-foot run, and then the other end I put it in ice water, and you see the pressure gradient, where the boiling water side is, the balloon blows up a little bit. The air inside expands enough to just blow the balloon up just a little bit, and that little bit of a stretch of 60 feet, you see a little pressure gradient just from temperature.
Okay, so within this pipe, the heat differential between the both sides is creating higher pressure on the side with the boiling water and lower pressure on the side with the ice.
Yep, that's right. What I did is I loosened the balloons up because I knew it wouldn't be a lot, but it's just, I mean, it's so simple of a demonstration, but really anybody in their minds can think about this. More heat, more pressure. So it's hotter here at the ground. It's where the gases are produced. They're produced here at the ground. I asked them, is there gas up there at the top of Mount Everest? And they reluctantly say, yeah. Okay, how the hell did it get there? It expands up there. Okay, there's got to be a point up there that stops expansion, because gravity don't cut it, right? Gravity is not in any of the gas formulas, not in Boyle's law and Charles' law, any of the laws. There's no gravity. Okay.
Those are basic formulas, Brian. Those aren't reality end all be all formulas that explain everything all at the same time. Those are basic formulas.
Yeah, but
Do you know of a formula that includes gravity, Biodual, when it comes to gas?
Yeah, sure. We can still use F equals ma.
That's not specific to gas, but you're saying just because
F
it's
equals
mass,
mass would be the gas, acceleration would be gravity. We could determine forces for it.
We've never disputed the fact that F equals ma. Okay, if you want to just say if I lift something up, it falls back down at a certain speed, fine. Okay, we've never disputed that. That's, once again, that is observable in reality. Now, don't you think if I had a vacuum, even a weak vacuum at either end of that PVC, that the gas would fill it?
Oh yeah, probably, sure. But
Yeah, exactly. Common sense.
I would
So
ask
don't-
you, I would ask you to introduce a force of 9.8 meters per second, and then introduce the vacuum next to it, and
the
then see what
force is
happens.
lifting something off the ground. Walk outside and tell me what's falling. The force is however you lift it off the ground, whether it grows up in the air slowly, whether you lift it up in there, whether you catapult it. That's the force, bud. The force ain't it falling back down. The force is getting it out of balance. Okay. This is just observable reality.
The only force we can measure, as far as I know, is the force of the object going either up or down.
Well, in any direction.
Yeah, in any direction. That's the only force we can measure. So it seems to me that the force comes from the object.
Sure, the mass.
The force comes from whatever it is, taking something out of balance. It's the same with temperature. It's the same with pressure. If you take something out of balance, it takes energy. I hate reifying energy, but in this case, you could call it a force. Okay, it takes a force to get something out of balance. A person, you know, whatever, electricity. It
Yeah,
takes
motion,
a force
right?
to get something out of balance, and we don't need explanation of why something goes. You just call it entropy. Why something goes back to balance, because that's the way it is. Now, my explanation, and this is interesting too, because Witsit kind of backed it up in a way I never thought of. What I showed in my videos, another video was how they flipped a fish tank upside down, and the water is under the air, and it stabilizes. So it's just sitting there, stable from them vibrating the fish tank at a certain frequency. Like if you take a Sawzall and you turn it on, I mean, that's just an example to give you something to think about. So they vibrate it at a certain speed, and the air is underneath the water, and then the boat is floating on the bottom of the water. They pull it down into the air, and it floats. I mean, it falls up and floats back on the water upside down. So my explanation would be is that, you know, there's a certain frequency to the earth that, and what Witsit said is, yeah, you know, that's where the electrostatic comes in. That's what gives Earth the frequency that it is. So if you think of something microscopic, okay, for their model, they give it a spin. But if you look at the shit under a microscope, and they'll tell you it's not really spinning, it's just vibrating. Everything has a certain frequency, okay, and it's vibrating, all matter. So there's no gravity necessary. It's just the way shit is. So if you take one of them sound generators and you put the sand on it and you get different shapes, you can turn them upside down. Okay, they hold their form. Okay,
They'll hold their form horizontally, not vertically, Brian.
No, that you can use sound to generate big stones and shit, like 50-pound stones on a little.
You could do a lot with sound. You're right. You're adding energy to a system, and in the form of vibration. And vibration makes things easier to move because they're exhibiting less friction on something. So as it's vibrating, it's not holding itself to the ground, so it's easier to move. Yes, I agree. There are certain sound frequencies in which you can levitate water. You can do all these things, but that's not negating or disproving gravity. All it's doing is it's more interactions and more influences that seem crazy. That's all it is.
Before you obfuscate too far, every molecule vibrates.
Sure, I do. Every molecule is moving. The only
everything vibrating.
Here, Brian. The only things that are not moving absolute would be under absolute zero, in which we cannot achieve. So yes, everything is moving to a certain scale.
Brian, you're saying everything is vibrating at a different frequency, right? Is there stationary objects that are vibrating at different frequency?
I'd say everything has a certain frequency, and you know, but I think I think would agree. Yeah, if it's not at absolute zero, it's what they call spin. Even, you know, they even say it's not really orbiting or spinning. They just call it that for the model's sake. It's actually vibrating.
No. Don't put words in other people's mouths, Brian. No one would say that it's vibrating like that. It is rotating. That there would be a key difference. And this is what I would ask you Brian. If you really think that these vibration things matter, what I want to ask is, have two things that are vibrating at different rates, different frequency, different amplitude. Hold on, Brian. Do these things with different objects, but similar surface areas. Go to a tall building while they are doing this vibration. Drop them at the same time. I predict that they hit the ground at the same time because the vibrations don't mean a goddamn thing. And I think for your hypothesis is that a different frequency would make it fall at a different rate. That's what I think. You can clarify your position, but
I think we lost him. Sounds like he ran into somebody. Oh, there he is.
So spin is not a factor. You know, they have like charge, spin. So you're saying the spin that they attribute to the models is actual spin of these electrons and shit? You saying shit's actually spinning?
I'm saying the entire system is rotating. But again, you may have cut out there. If you think that it's things are falling or have an interaction because of a certain frequency, I would recommend doing an experiment. Get to a tall building and have two objects that are at different.
Nothing is falling.
I don't give a fuck what we call it now.
And guess what? Nothing is falling. Everything's just sitting there. Now, if you add energy, if you add energy to heat, you can melt the water and it'll evaporate and it'll rise up in the air as a cloud. If I pick this ball up and throw it, if I catapult something, if I have to add energy to get something to move at all, buddy. Nothing is going to move at all.
You have to add energy and you provide a force to everything. You're right.
Quit applying a force to something returning back to balance, bro. Quit doing that.
It's not returning back to balance.
You're never going to start an experiment with something in midair, bro.
Brian, let me just ask a simple question. If I throw a baseball straight up, are you saying that it's out of balance? If you do, what is it out of balance from?
There, Brian. He must have got busy.
He probably meant to say out of equilibrium.
Yeah, I think that's what he meant.
And then it comes back down.
Right. It's just force.
Yeah, same thing if I take a beach ball and I have to bring it underwater. Okay, it's coming back up. Okay, no force necessary, people.
Yes,
it's the balance of things. It's the natural order of things. There's nothing you could do about it.
The predictive power requires gravity.
To begin with is because they have the Earth spinning. Okay, they have a round Earth and they have to have it rotating. So that's why they needed gravity to begin with. They had to have a force to keep everything down on the Earth, right? Travis pointed that out. That was well put.
So I'm with you on the observation that things tend to find their equilibrium. When they're taken out of equilibrium, they could try to go back to it in most cases. But this whole thing with vibrating, I haven't seen anything. I don't know anything about that. If vibrating is the reason things fall to the earth, I haven't seen any evidence for that. Maybe it's out there. I don't know.
It's just the principle of everything. If you get to the quantum scale, if you get to this tiny scale, everything is exhibiting some type of movement. You won't have an atom or molecule. You won't have these things in absolute stillness, because that would
everything has a frequency.
That would assume no energy, meaning absolute zero. We can't have that as far as we know, as far as I know.
Would you agree that everything has a frequency, right?
It's on the most technical of scales in which things are always moving in some way.
Okay. Anyway, let me bring something up real quick here. Oh, not this crap. This equatorial mount video. Sorry, WS.
They made a numpty clip out of that.
Out of this one?
WS you were talking. I don't know if it was WS you were talking to, but what you are in a numpty clip that is all about an equatorial mount.
Oh, I heard that one. WS has been bucking me about equatorial amounts for probably years now. And one of these days I'm going to get around to showing him why it doesn't falsify a flat planar surface. But this video is hilarious. The cartoons in it that this guy shows, so he's using this trying to debunk flat earth. Wait till you get to the flat earth model. This is how he envisions an EQ mount would work on a flat earth. So he's got his mount here, he's pointing it up towards there, and this is kind of the Professor Dave thing here. This is how he pictures the Earth would look and work on a flat plane. And we're supposed to take this seriously. Come on, man. Look at this thing.
Provide a model and then we can analyze it. But until then, people are going to come up with whatever.
With this, you think this is worth coming up with, making a video about? Go, I debunked flat Earth. Here's this crap.
Well, that's what I'm saying. Provide a model, and then we don't have to make shit up.
Well, what's he debunking? Why is he making shit up and debunking it and telling everybody that Earth can't be flat?
Equatorial mounts exist. They do work. However, we can't. However we try, we can't make them work on flat Earth.
Really? When were you on flat Earth and try it?
I am now.
Oh, Chikey, you just conceded that flat Earth because you just said you're on a flat Earth. Chikey,
yes, right.
Damn it.
So why can't I model it? If I'm on flat Earth and they work, why can't I model it?
Because you suck at modeling it, obviously.
Then you do. Please.
But see, the thing is, you have to point due north at midnight to point at the sun, and that does not comport with what we see in the daytime as an EQ mount would indicate, right?
An EQ mount is built to go around, right? It swivels. Here, there's a video of it. It swivels. This is showing the Earth move, but the EQ mount swivels like this and follows the celestial objects across the sky in a arc. There's a name for the arc. And then once it gets to the horizon, the celestial object, and is no longer visible, the EQ mount swivels around because it's built on a swivel, and it just points to the ground. And if you time that right, you can time it so that when the star or whatever you're tracking comes up from the opposite horizon the next day, it'll pretty closely track to where it rises the next day. Now, just because a mount is pointing at the ground once you can't see the celestial object anymore does not mean that it is still tracking that celestial object. It just means that's how the tool is built.
Unless the globe is spinning elliptically.
So your conclusion that as long as you can see the star, it tracks it right. Somehow at night it stops tracking the star.
Yeah, so this is going to be a tough one for you to wrap your head around. But yes, when an EQ mount is pointed at the ground, it is no longer tracking a star.
Well, in your mind, I would say
in
that
reality,
because
it's not.
The same thing that Left Lane asks about where the sun is at sunrise. Point to it at noon, point to it at sunset, point to it, and then at midnight, point to it. It's the same principle. I would point at the ground at midnight because in the globe model, that's where the sun, give or take, would be. An equatorial mount would be doing the same thing for celestial objects, obviously.
Well, that would be silly to point at the ground when a star goes past the horizon. Just because now let's say I understand why you think that, because you think that the Earth is a giant ball and it's spinning around and the star is on the other side. But trying to say that an EQ mount, because it swivels and points at the ground after you can no longer see the stars, is proof that the star is below your feet on the other side of some imaginary globe world is pretty silly. Wouldn't you agree?
It's evidence. It's evidence.
It's not evidence.
I'm not saying, I would never say that it proves a sphere, but it's evidence for a sphere, and it's also evidence that it doesn't work.
It's not evidence for a sphere. This is a man-made tool that is made to swivel across the sky to track a celestial object. So we made it work that way. How else would you make something that swivels in a arc like that across the sky, except to complete? You can make half an arc and put stoppers on the joint, or how would you do that?
So at least
Brandon,
for the time
there's two problems they're not pointing out, bro. Okay, unless the Earth is either rotating in an elliptical rotation, which is retarded, or if you take that half circle, okay, that's with about 15 hours of daylight, and you're only got about 9 hours of darkness, and it's doing a perfect half. Then you have the swivel itself rotating on two mounts. I mean, on two two axes. Okay, if I'm only supposed to be spinning in one direction, and then why is it swiveling on two axes? But really, the main point is the Earth would have to be rotating elliptically.
You're on a curved surface, Brian. That's why.
Listen, if you
Brandon, another part of this, another part of this equatorial mount is that the way that it's moving and following the star is a consistent rate. If we're on a flat Earth looking at whatever shape it may be on the ceiling, as things get further from you, they're going to start slowing their rate of
That's what people
appears
think.
to be
Every
knowledge.
time
So
you
these
guys
equatorial
say,
mounts-
if we're on a flat Earth, you fuck up. I just want you guys to know that every single fucking time
provide
you
a
say
model and we
that,
don't have
I
to
don't
do
know
that.
what the fuck you're talking about, and the next thing you say is ridiculous.
Provide a model and we don't have to do that. Until then, if
You
we're
don't
on a
have
flat
to do
Earth,
it now.
Oh no, we can. We're testing it. We're testing it. If we're
You're
on a globe,
testing
if we're on a
nothing.
flat Earth, there's going to be discrepancies, obvious discrepancies.
You're
between each
testing
observation.
your lame, half-baked, straw man, flat Earth model like this one, and the one Professor Dave acts like he's the smartest
provide
fucking
one.
guy in the world for coming
You're
up
mad
with.
at, you're mad at us for testing your theory.
I'm
but
mad
you
at
won't
for the
correct us.
dishonesty inherent in presenting
Then
something
correct
like
it.
this and calling it a model.
Then correct it.
Well, I don't understand.
We will.
Forget the knife.
We're waiting.
Forget
Until
the
then,
time.
we're going to
Well-
be testing what we think it is.
Forget the
That's a
time.
waste
We
of time,
can't see
just
the
so you know.
object. Forget the time. We can't see the object. Focus on the time. We can't see the object. Tell us how this object is moving above the flat Earth that will make the equatorial mount work.
Sure, it's pretty
You gotta
obvious,
go back to
but okay.
2015, bro. I'm not going back to the basics for you, Chucky. You don't understand how perspective works. If you don't understand how perspective works, listen. If something's in the center, okay, it's doing a circle around me, and I'm in the center. Okay, as it comes around, if it's at its maximum distance away from me, as it spins around to the right, okay, it's going to move further to the right. Okay, now as it gets closer, just from rising up in the air, it's going to appear to move left. Just from it going up. You could draw this on a piece of paper. I just demonstrated about 4 videos ago on Flat Earth Test channel, where the perspective shows how the sun does a circle. Same thing with the stars. Okay, they do circles. I show how perspective ties it in. Just something going up in the air will make it appear further left, and you can draw it on a piece of paper to understand it. It's very simple.
Draw it on a piece of paper.
Yeah, I've already drawn it. I'll show it. I'll turn my camera on if it'll let me, and I'll show you.
First of all, where do we use an EQ mount?
Just observations of celestial bodies.
No, I mean, we
likely
use it
for,
on Earth,
long
right?
Exposures.
On
Most
Earth,
likely
right?
long exposures.
Have you
Yeah,
ever
sure,
been
on
on Earth? Does this look like Earth to you?
It looks like a projection of Earth on a flat plane.
It looks like a 2D representation of Earth, pretty much, right? A
Pretty shit
Euclidean
one. Pretty shit one, but yeah.
We don't live on a that, and we don't see like that. That's not what we're measuring. When we use an EQ mount, we are tracking what we see, right?
The apparent position of the sun, not even the actual position of the sun. Who knows where that is? We're just tracking the apparent position.
Just rhetoric. Yes, what we're seeing, especially if known positions according to your latitude. Yes.
So this isn't how we see. We don't see from this position all the way to the edge, do we? Nothing looks
that would
like
be
that.
a prediction. That would be.
I'm
a
looking
prediction of a flat
here.
Earth.
This part of the continent is the same proportions as this continent over here. That doesn't make any sense. That's not how we
No,
see.
like I said, it's a shit representation, but it's a projection on a 2D plane.
So
but it's still
why
a
do
shit one,
we
yeah.
get these kind of debunks of a supposed model, a thing that's supposed to falsify the concept of living on a flat plane? But this is so half-baked that you even acknowledge that it's shit, and I don't think I've seen a better one than this. It's
The parts that
always
are shit
this.
don't apply to what the argument is. That's the point here. So Africa and Asia can look like shit. They could be unproportional. That's fine. What is being demonstrated and what the argument is has nothing to do with the parts that are shit.
No, this is nonsense.
Oh yeah, I know it's nonsense. It's flat Earth. Yeah.
No, I mean, this is globe shit. This is nonsense. This is what globers think flat Earth is. That maybe that's why you guys think it's nonsense.
It's
is because
totally
you
possible,
imagine
sure, yeah.
something like this fucking, what is this, floating in space still? What the fuck?
Right. See, but that part's not part of the argument. That's why you're hung up on it. But again, if you want globers to not create shit models, make a good one, then we can analyze that one. But until then, you and I are stuck with shit models.
Just to be clear, if you don't provide something for them to argue against, they'll make up whatever they want and argue against that.
No,
And call you stupid.
We'll follow the logical conclusion to what is being described, such as on a
Bro,
flat
just use the AE
plane.
model. The globe is an AE model projection, bro.
No.
Here's the most basic way I can put it for a flat Earth. The most basic way, most basic question. I think I've heard Jem say it. I'm sure you've heard me say it as well. If you're on one side of the planet, I don't give a fuck where you think one side is. If you're on one side of the planet and you establish a horizontal line at sea level, if you go to the other side of the planet, again, I don't give a fuck where that is. You go to the other side and you establish a horizontal at sea level. Those two lines would be the same line if they're pointed at each other. That would be what a flat Earth is in my mind. So when I see these models, I think that's a perfect representation of what it basically is. The actual sizes of these land masses, sure, it's all fucked up, whatever, it's a projection, but that's not the argument. The argument is that it's sea level, and you have the same horizontal line. That would be the basis
you
of a flat Earth.
misunderstood why I criticized the shape of the continents. Because this isn't a perspective-based view. He's got a Euclidean model that he sat this scope on, and he's moving this around, trying to say that this debunks vision perspective-based observation and how the tool's used. You have to debunk it within the world how we see it and show how that falsifies a flat Earth. You can't plop a fucking thing down on what we don't experience and tell us that this debunks the flat Earth. That's
you can
ludicrous.
Again, this is when you assume a sphere Earth and you assume a flat Earth. There are going to be very clear distinctions on your observations. For a sphere Earth, you're going to be able to see bleh. On a flat Earth, you won't see that. You'll see bleh instead, or whatever. That's what you're doing, and then you base that off of reality. In reality, we actually see this. Okay, this lines up with this model, and not so much this one. And you go down that process. You can make these assumptions on both. It just sucks that we have a basically complete globe model that everyone likes to rip apart or try to, but apparently we have shit all for a flat Earth model, and we want one. Of course, please provide one.
Bro, go to Steve Torrance, okay? It's all modeled, okay? All the planets, the Earth, it's all modeled in it.
Didn't he just make it fit though, Brian? Didn't he just make it fit? Brian, didn't he just make it fit though? Is it based on experimental, empirical, logical data, or did he just make it fit? Because I'm not going to adopt a model just because he made it fit.
Who is this? I would like
Steve
to look.
Torrance.
I've never seen it.
Steve Torrance, Torrence. Okay, all the information's there. It's terabytes of information, and it all matches reality. Okay, you want models. You don't like common sense. You don't like demonstrations. On this channel, we like demonstrations. The way I demonstrated the pressure gradient, the way we demonstrate all kinds of other shit. Okay, we don't like just you're stuck in your head, bro.
I know you say that, but I'm trying to find this model right now. Is it an actual website?
It's terabytes of information. Once again, terabytes.
Right. Where is this information?
It's going to take you a few days. It's going to take you a week or so to watch it all.
I could give a shit, but that's not important for what I'm asking. Where is this information?
Steve Torrance. That's the name of the channel.
What channel?
Yeah, I got it up right now.
Steve Torrance.
I think it's really dumb that whenever you're trying to talk about what reality is, that you're requesting or demanding a model of reality instead of just pointing at reality. Why are you insisting that somebody imagine up a representation that can't possibly represent all of reality instead of just pointing at the reality you literally have available to you every second of every day?
I understand his globe model's broke. Listen, I understand his globe model's broke, and he wants something better. He wants something better because his globe model's broke. Well, there you have it.
Perfect. So instead, I'm going to speak for myself. So Bob, I understand what you're saying, and yes, that is what we do, especially when we talk about the particular angles to particular stars, such as Polaris, and you go to different latitudes. That would be part of the evidence. And then refraction. I don't give a fuck,
That's
Brian.
on my channel too.
Okay, Brian, I don't give a fuck, Brian. So now when we talk about whether it's a sphere or flat, we have to have a basis of what would we expect to see with each type of model?
It doesn't work on the
No, you
globe, bro.
don't.
You have to
Like, that's
invoke
the thing is that
refraction.
you don't actually need the model for anything. You can just look at reality and say, here's what reality is, and that's what it is, right?
Right,
You
we
can
have
point
done that,
tree
and it's a
say,
sphere, but there's an
a
argument
tree.
that exists.
It is a tree. Now, you could have somebody come up with 50 other ideas of what the tree might be, but you can just point at the tree and say, look, that is a tree.
Okay, that's what we do, Bob. And it was the
No,
Earth
it's
is
not,
a
bro.
sphere. Hold on, I'm gonna get to the fucking end, Brian. Calm
Yeah,
the
go
fuck
ahead, go
down,
ahead.
goddamn. So when we're talking about all these evidences and observations, it's not that in the beginning it was, is it sphere or flat? We have to have models. Now let's go look. No, people just fucking looked and then determined it was a sphere. And then based on the observations, a model was made based on the observations evidences. What's happening recently now is that people are saying, oh, no. These observations don't work for globe, they work for flat. The Earth is flat. So now we have two opposing ideas of what the Earth shape is. So yes, we need models for both, so we can have predictive power. We have predictive power of what
we
we would
don't need a
expect to see
model.
in
We
reality.
can just point to the reality and say, look at reality and let's see what it is.
If it was
Yeah,
that easy, there would be no
Why
debate.
would you go to,
Just
if
a
the
second.
model obviously has failed, okay, or isn't demonstrating
hasn't.
something well enough, then obviously it would make sense to go to the thing that actually is happening and just point to that instead, right? So
Well,
like if we're on a big ball, then you should be able to go point to the curvature and just say, see, there's the curvature,
Yeah,
so
Carnivore
it must
posted.
be
Yeah.
curving.
That's a good
the
point.
reality.
Can I say something? I think Bob is kind of right. I understand where he's coming from in that a model, I'll define how I think of a model. It's a description of something in reality. So if you have a model or a description of something in reality, globe or flat, I should be able to look at each and every part and implication of that description and find a match in reality without contradiction and without fail. Would you agree with that?
To a certain extent, if you're being scientifically honest, you're going to have anomalies, and then especially atmosphere, you will have differences. But generally, 99% of the time, sure.
Okay. Yeah, I agree there'll be anomalies, and then you should improve your model and go, okay, well, here's an anomaly, and your description should include and allow for that anomaly.
Sure. But the problem arises when something is brought up in which this doesn't fit that model. But that person who's saying it doesn't fit is misrepresenting the model, and that's where it goes down.
Your model breaks right out of the gate.
Yeah, but that's what I was complaining about, BioDual. That's what I'm complaining about, and I understand we haven't given you guys a model. We haven't given you a what you have for the globe. You can calculate based on all of these variables and how they were named under heliocentrism, and you can calculate assuming that what you're seeing is due to curvature, and you're pretty accurate. So you're looking for a replacement. I agree that is a necessity at some point. If our goal were to have the world adopt a flat Earth model, we'd have to have them understand that the Earth's flat, but here's how it works. And instead of those calculations, use these ones.
I just want something to test, man. I want some predictive power, and I want to test something. That's all.
Let me explain like this. Like I live inside of a house, okay? And I'm guessing that nobody on this panel right now has ever seen the inside of this specific house, okay? The one that I'm living in. As far as I know, none of you live anywhere near me, okay? So let's say that somebody like BioDual or whatever says they have, without seeing the inside of my house, come up with a model of what my house looks like on the inside. And they have certain, assumptions that they've made and certain predictions, like it's going to have doors going into the rooms and it's going to have some windows, okay? And some of those assumptions are going to be correct because there's certain things that you can just assume that make sense in a house, okay? For him to then demand from me a model to prove what my house is on the inside is ridiculous when I can just say, come inside the house and I'll show you what it looks like. Here it is. This is the house. And it doesn't matter what either model, you could have 1 billion models and none of them would matter. None of them would be as good as me saying, walk into the house and look at what it is, no matter what the model says.
That's with all due respect, Bob, that was the dumbest analogy I've ever heard, because that's not how any of this occurred. It all occurred with observations and
I didn't
evidences
say
first,
any of
and
it
then
occurred like
and
this.
then it
I'm
matched
saying
particular
that's what
things.
it's like, and it is.
It
All you
isn't.
said was
Hold
it's
on,
dumb.
hold on. Your
Worst
model
analogy,
falls
man.
apart right out of the gate.
You
What,
haven't
what
seen
does everything
inside
do
of
that
the
goes
house,
away from us, bro?
and you're demanding that I give you a model.
He said
to
he
show
wants
you what the house
predictive
looks
value,
like.
Bob. Bob, he wants predictive value. What you described doesn't give him any predictive value. You can't predict anything.
So
with
he
what-
doesn't care what the house looks like on the inside. He wants to be able to predict ahead of time what it'll look like on the inside. Is
Yeah,
that what
because
you're
there's
saying?
practical applications. I'm going to build a house. I need to put post here, 1,000 feet from here, 2,000 feet from here, and I need to connect them by a straight wood. I need to be able to predict how much wood I have. You know, that kind of shit. There's not that they do that for anything, for the globe, for anything, mind you. It's all based on flat planar math. But
No,
that's what
it's
he's
like- it's just
asking
like the long
for, is to
distances.
be able to use it for predictions.
Right.
Okay,
Like
wait
if
a
you,
minute, wait a
it'd
minute.
be,
Hold
it'd
on,
be
hold
one
on,
of those
wait.
things. Like if you
That's not
told me,
correct, though.
if you told
Hold on.
me how many steps it took to get from room to
It
room,
absolutely
if
does
you
give
had
him the predictive power he's asking for. It absolutely does. If I let him step inside the house and look at the inside of the house, he will have absolute predicting power for everything inside that house and how it works and how it interacts. He absolutely would. And that's exactly what we're talking about with the models, is they don't want to predict new things that have never happened before. They
course
want
they
to,
do.
quote unquote, predict things that continue to happen over and over. Like, let's say, weather. Okay, let's say stars and planets and where they're going to move. They want to say where those things will be at some time in the future, the same as they have been in the past all the time. So stepping into the house and looking at it will give them the exact same predictive power they have with their alleged Earth. Is they would have looked at things first, they would have looked at the inside of the house first, and then determined what's going to happen inside the house based on what's inside the house.
Now, I agree with you fundamentally, but here we've got these people who have got equations for stuff. Let's just say gravity. And it's all couched in this idea of the heliocentric model. So they do want that part because they want that theoretical part. It supports their heliocentrism. But I hear them asking for something that replaces it, that is couched in the world being a planar stationary system. That's what I hear. So you calculate
Just something
gravity
with
by its
predictive
space,
power.
its curved space time. You know, we'll come up with a new thing. That's fine. It'll be predictive. All we would have to do, Bio, is take your equations and change the variables and the story that goes with them.
Perfect. And then we could test all of that you provide. As soon as you
Yep.
provide it, we'll test it. Sure.
Okay.
Can I just say it's been done? And just to answer Brandon's question earlier about Steve Torrance's model, is it a reverse engineer, basically, or is it a predictive thing, and or has it been made from real observations? And I'd say yes. I'd say
Really?
both. In all honesty, he started off the model by basically getting NASA JPL's data, which is basically time and date .com data of when the sun sets, when all the planets sets. Yep. And he reverse engineered that onto a AE map, basically above an AE map. He presumed that everything's around about 4,000 miles above Earth, above a flat Earth. And then what they did on top of that, him and Dr. Zach, is they took, I think it was 300 data points from flat earthers all around. They'd done back then it was I think there was something else that they'd done it on. It may have been Facebook, but they literally got them at particular times of a certain day to everyone to give their angle to the sun. And then they created the model or modified the model to match that. Now, on top of that, Steve then personally went to Spain, to Tenerife, to somewhere in South America, North America, and tested his model against star trails, and he found that there was a problem. Now, to resolve that problem, he actually resolved it. He actually added refraction, which is built into the 3D Max software that he's got. And once he added refraction, once he sorted out the lens, it started to match the actual star trails that were taken in reality on a camera from the exact location.
Can you provide a link to this, please?
I'll pop them all in the general.
Would it resolve it
awesome,
to another location?
I'd
Yeah,
rather not
he
call
done.
bullshit
Or would
without
he
seeing
have to remodel it?
He done 5 locations, and his model matched the actual real life star trail that had been captured by a photographer. Give me 2 seconds.
Okay, now if you take and you spin, this has been demonstrated. I'm gonna pop a link in general in a minute, but it's shown if you rotate the object, if you rotate the camera, unless you're pointed directly at the North Pole, you do not get the star trails we see. If you're pointed off to the side of the center, you will not get concentric circles at the North Pole. It does not work on a globe. I mean, if y'all are talking about the stars, it falls apart just in common sense, okay? Middle school teenagers can debunk this shit in their head, dude. Think about it. If you're spinning a camera, if it's the camera that's spinning and you're not pointed right at the center, you're not going to get concentric circles, man. It doesn't make sense, man.
If your camera's pointing at the celestial center, yes, it will, because your
But
point
even
of,
if you
your
line
point of
your camera
reference,
up off
your point
center,
of
you
reference is
still
in
get.
the middle.
Here's my point. You still get the circle. You just get the portion of the circle if you're not pointed at the center, even if you're not centered. And that, I mean, that breaks down the globe right there, just right on its face, dude. I don't know if you understand what I'm saying.
I don't really, because the
That's
base
why I'm
point
gonna that's why I'm gonna post it in general. Give me about 5 minutes.
You know, I
Alright,
think
man.
you've mentioned this Steve Torrance before, and I've meant to look into it and watch his videos in detail and never have. Well, this sounds pretty cool. It sounds like something everybody should check out if they haven't, see what he's got going on. The Science of Science, super chat at $5. He says, "Yep, we all did tracking the sun." Oh, that's cool. Yeah, I'll look for that. Thank you, Science of Science.
Think about this, Brandon. During the eclipse, you've seen the shadows through trees, how there's like a million little eclipses in the shadowing.
Yeah, that's weird as hell. Yeah.
It's the same type of modeling. Okay, the way the sun is, they just to settle their problem, they just put the sun 93 million miles away or whatever, 5 million, anything past that. Okay, but in reality, it's something more than that. It's like, and like I said, my example would be, like I said, during the eclipse, this solar eclipse. You look at the shadows produced through a tree, through the leaves and all that, and you get like a million little eclipses. That's an example of the sun pointing different directions, like a million different suns, basically.
You know, it might turn out that some of the way that the heliocentric model conceptualizes things and the math and how you imagine these planets to be in different places, it may turn out that those are more elegant and simplified mathematical models. But that doesn't mean that we're standing on a fucking giant ball. Those two things are not mutually exclusive.
You understand? Angles. The sun and all that doing 360. It's just simplified. It's just to do the math. It'd be a nightmare trying to do the refraction math and all that, like Steve Torrance did. The reality, they only invoke the refraction when they want it, when their model needs it. It's a simplified model of what's going on in reality, but that don't mean we're on a globe, like Bob said. Where's the fucking curve?
Right, where's the curve? Yeah, I haven't seen it. Anyway,
again,
would you like to?
Sure. You got a picture of it?
I have direct measurements of it.
All right, let's see it.
Direct?
No, you don't, man. You don't, because when I went down the coastline, when I went down the coastline, they said
actually does, Brian. Okay.
They said that I'm curving myself around a ball, and I just don't know. Measurements do not. You don't produce them with auto levels. They say that I'm working my way around the globe, and I just don't know it.
Direct measurement would mean direct measurement would mean that you didn't do it optically, and you didn't have to calculate any refraction or anything. So how do you do it tangibly?
It's done mechanically, it's done via laser, and it's done via radio waves, depending on what level.
How
Do you have
None
it?
of those are direct.
A mechanical measurement is a direct
Let's
measurement.
walk them through it. Just go ahead and bring it up. We'll walk you through it, buddy.
Yeah,
Go ahead.
hold on.
Bring it up.
Let's hear the mechanical.
Bring it up.
Another 2 hours.
Let's see
Sure.
it. All right.
It's the David Taylor Memorial Model Basin.
Huh? I've never heard of that.
The David Taylor Memorial Model Basin out of Bethesda, Maryland. It was built at the advent of World War II by the U.S. Navy Department, and the water that's housed inside it, I think we all agree, water is level. But 18 inches above that water is a rail that the crane runs on that was manufactured with a curve. However, at every point on that rail, it's 18 inches above the water, as verified for the last 50 years.
Well,
every 3 to
how
6
long
months.
is this rail?
So it's flat.
Hold on. How long is this rail?
450 feet.
Is it all one piece?
Yes.
What material is it made out of?
Iron.
How much does a curve in 450 feet?
Not very much at all.
Yeah. It's
They actually
basically
had to come
flat,
up with
450 feet.
They actually had to come up with brand new manufacturing techniques just to make the this rail possible.
Well, they wasted their
That's called
fucking
a
time.
story. That's called a
The way they
story,
make
bud.
mirrors, the way they make mirrors and they float them on mercury, liquid mercury, to get a perfectly flat mirror that works. Okay, but the mirror we see on lakes and at the salt flats are curved though, so we're basically seeing a sun curved reflection off the water. No, bud, just go out in fucking reality and look at reflections, bro. It's not fucking curved. I repeat, the water is not fucking curved. For God's sakes, man.
Hey,
Okay, then
who is that,
why is
Badger? Or what's your name?
Why is my name?
Yeah.
Kool-Aid.
Kool-Aid's, I would be interested in seeing more details if you have something more substantial than what you've provided.
Sure, I'll
but
send-
that
I'll send
doesn't-
you the exact.
Okay.
I'll send you the exact details. I'm just gonna get screamed over here though.
These people are
That's
desperate.
not
Dude. They're
that's not a
talking-
direct measurement, by the way. That's you taking the word of the manufacturer, saying they designed it with a curve, and then saying,
They're
"Oh,
desperate.
well, I believe you that you designed it with a curve and then manufactured it with a curve." That's not a direct measurement. That's you believing a story you were told.
Yeah, I wonder what the tolerance is for a 450 foot long iron rod. How much that would bend under just its own weight.
It
How
actually
long-
doesn't bend because it's set on the bedrock specifically to avoid that issue.
No, but I mean, if you held that thing up, like if you could somehow hold up one end, let the other end dangle along with that, how far would it bend? How, what's the right word? Elastic? What's the elasticity? There's another word. Elasticity?
It would probably break.
Plasticity.
What he's posted is proof of a flat Earth. Okay, let's get this straight. 18 inches above the water, it's proof of a flat Earth.
18 inches at every point, regardless of the curve of the rail.
But it's not curving that much, though. That's the problem. It's 450
Right.
feet.
It's
There's
only
like,
It's only 450 feet, right?
yeah,
But it's direct measurements of the curvature of the Earth.
it's got to
what
be
you
like,
asked for.
what
Not a
is
direct
it? I mean, we can look it up. What is 450 feet worth of curvature?
Yeah. What's the curve? What's the curve on that?
I think it's like
4,000
of a
Yeah.
foot.
First of all, you got to cut it in half because you got to go with
4,000th of a foot?
horizontal spot in the middle.
4,000th of an inch, you said, Bio?
Yes, you got to cut it in half because both ends are looking down at it, right? Isn't that the way globe Earth works?
Oh, the Sagittarius, yeah.
How much is the
No,
Sagittarius?
by
supposed to be at?
by four. The Sagittarius
Yeah,
is 1/4
It's more
of
than
the
half.
curvature.
By 62. You got to cut it in 62s because then the math won't work and we're wrong.
No, it is by 4. The Sagittarius is 1/4 as high as the curvature. That's globe math.
Cool. Doesn't change the fact the rail's curved.
The thing that you
Uh,
haven't established yet, but you just believe a story
Sorry.
you were told.
Sorry,
It doesn't change that.
how much is the Sagittarius? Over 450 feet?
It's 1/333rd of an inch. That's the curvature over 450 feet, Biodual? Somebody said it was 1/4000th of a foot. Who was that? Anyway, if it's 1/4000th of a foot, if that's the curvature is 1/333rd of a inch. Of an inch.
Yeah, which is why they actually had to come up with brand new measurements.
Yeah,
this is the tank that the only thing that ever goes in this tank is model boats.
I think
literally a toy boat barn.
I think if this rail or whatever he's talking about actually was curving, you wouldn't even be able to measure it.
Yeah, no, that's what I'm trying to say. 1/333rd of an inch, dude.
Yeah, they actually have submicron measurements to the surface.
Yeah, but
and this
dude,
is perfectly still water. There's perfectly still water, no waves or anything.
What are they doing with what are they doing with this rail that they need that kind of precision? What the fuck does this rail do?
Good point.
They are testing toy boats to see new hull designs and for both surface and underwater fleet.
Bro, nothing needs that. Come on, man. Toy boats need 1/333rd curvature over a. Come on, man.
Yeah.
Is this a joke? Did you make this up? Are you making this up? Is this a fake story?
No.
Bro, they don't even manufacture precision engineered shit to that much of a degree.
If you actually look back through the history of the U.S. Corps of Engineers and you follow the standards that were specifically designed for the model basin, you will find a manufacturing technique that does have the tolerances and also
they might have it.
prohibit.
Can you check the general chat, please? I posted a Weiler product that's a water level with the micrometer built into it, and there's a third paragraph I also posted. Read the third paragraph.
Read it for us, Rob. You have a lovely voice.
Third paragraph.
I got a lot of noise around here. I don't have time to read it, but please.
This water level is used with great advantage for leveling at big distances in machine construction or when erecting lines of shafting or other work with widely separated bearings. Is that it? Rob? Okay.
Yes.
Okay.
Yeah. What's the maximum range on those?
Does it say on here? Is there
No,
one?
it doesn't, because there is no range. It can be any length.
Don't you start getting into trouble with the hydrostatics and water pressure and shit when you go further? I don't know if that's true. I just heard that that's true. Like if you were to try to do a 10-mile water level,
it takes longer. It just takes longer.
Oh, okay.
It just takes longer to equalize.
Got it. Cool. Well, this is a cool story. I like this story about the 1/333rd. I like that part especially. That's a nice touch. Of it.
Don't you have to divide that by 4 though?
No,
you
that's
have to divide it by
That was the
372 to make it some
Sagita.
obscurely small number. Who cares?
It
Numbers
is-
don't matter.
Dude, you can't measure that. Fuck that, dude. Go out to that rail and show us the curve. You have no idea. They might have bent that thing on accident, and it would have been more than that.
Grab a ruler and get 1 inch of it, and you cut it up into 300 equal-sized pieces, and we can talk about one of those pieces and going out and checking that curve.
Yeah, I wouldn't be able to now with my eyes.
To us when you've divided an inch 300 times.
Well, we wouldn't use a ruler or an inch.
Are you saying
something more
lasers?
precise.
No, it's got to be
Lasers can't measure
physical.
that?
Cut something
I'm
physical
saying
up
you
into
haven't done it, and you said you had direct
1/333rd.
measurement.
Yeah, my wire
about
has a diameter that's smaller than that.
So you're telling us about
There
the
you go.
curvature of a wire over 450 feet? That's the best you guys got right now?
Well, I wouldn't provide that.
Yeah.
No, I just wondering.
You're better. You're better than this, Maya.
It's kind of the same as providing the blueprints for the LIGO and then showing the Sagita effect there.
Which is why they won't let me at LIGO.
You don't have a sagita in LIGO. Where's your water next to LIGO?
The blueprints show it, part of the construction.
You need to have water next to it though in order to show like there's a sagita there, right?
If you want to claim that blueprints are wrong because you arbitrarily decide that, then that's fine. But that's the argument.
Okay, let's say you have a straight line. You would need to put water up to it to know that there is in fact a sagita.
There are many methodologies that you can use.
How'd they find the sagita without water?
Construction of it.
Blueprint.
How did the blueprint tell us that there? Hold on, Brian.
And there
How
it
did
is.
the
There it is. Brian said
Hold on, Brian.
blueprints don't mean shit.
How did the blueprint? How did the blueprint show us that in reality there is a hump of water going over
Because
the, you know?
Just because you deny it doesn't mean it's not there.
The
Just
blueprints,
because you claim it.
only work on
Hold on.
one.
Just
So
because you. Just
if-
because you
if-
claim it doesn't mean that it is there. Just because you claim it doesn't mean that it is there.
Drew on some blue paper
Perfect.
doesn't mean it's there either.
Yeah, perfect. So this is all rhetoric. So the point is that there are blueprints for the construction of something, and we would all acknowledge that this would be the straightest, longest man-made thing. Blah blah blah. You could say universe. I can give two shits, but
The
it's
tube.
designed to be perfectly straight, or at least as
The
perfectly straight as we can.
tube.
So then when we see what the blueprints are providing in the construction of it, for that amount of distance, for that to be straight, would implicate a flat and sphere Earth in particular ways. The blueprints follow a spherical Earth.
For the concrete housing. You built the concrete housing with a curve in it. You don't have the blueprints for the laser tube, do you?
The blueprints are the orientation above sea level for each end, as well as the middle, and then many points from beginning to end.
I don't know.
Why I pulled it off?
So you mean gravity's not bothering it at all?
Hey, Rob, mic's open. I'm muting you because your mic's open, Rob. Okay, there we go. Anyway, so what else is going on? We got a
I
400.
appreciate you taking a moment to look at it and address it honestly. Thank you. I do appreciate that.
Oh no, I appreciate you bringing it to us. I didn't mean to laugh. It's just so small.
You're right.
And
It is a tiny amount. I agree.
You know,
I don't appreciate it. You just wasted all of our time.
At least it's something different from the day to day.
Well, yeah, that's true. There's something
Well,
different.
Let me just say something. We're always open for new evidence here. At least I am. Always. If you got something new, I don't even care how fucking crazy it sounds. Because some of the shit I believe is way out there. Bring it.
I talk about one thing, and that one thing is sailboats. That's all I know, and that's all I can talk about.
Really? Have you ever sailed in the
Yes.
South in any of those races or anything like it? What do you do with sailboats?
I've never done any of the races. When I was a kid, I did high school correspondence from a sailboat. I grew up on sailboats.
Oh wow. I think I talked to you before at some point. You told me that story. I heard it. That's cool.
Probably. I'm one of my big other proofs I love to talk about is the Vendée Globe, which is the race. I got really into it the last sailing and spent way too much money tracking it, to be honest.
Really?
Of course.
Why does it cost so much money to track it?
Because I was paying people for to do favors for me, like go down to the dock and take photos of the Hugo Boss in dry dock getting repaired.
Holy shit, dude. That is hardcore. You have to be obsessed. That is
a little bit.
Okay. All right. Well, that's kind of cool,
Unfortunately,
man.
I've also done the math on it, and on the AE map, there's 40,000 nautical miles that are missing.
Oh, based on how far the sailboats go?
Right.
I think you got. I think the Globers fucked up the map, though. To be honest, I don't think we have a good map right now.
But it matches what they sailed.
The globe matches what they say. Yeah.
Yeah.
How would we determine that though?
So
well, it brought them safe home.
No, but I mean,
Yeah.
how do you track it over the water? And I mean, how do you physically, in reality, practically know how far the boats went?
Great question. So the way that we can do that is, first of all, this is a fully technological race. So we have the computer readouts on what they were recording on board at all times. Second, we have the first-hand observation of the skipper of the boat. These skippers are the best in the world and are very well connected with their boat. They know exactly what's going on it. Third, we have GPS tracking data updated every 5 minutes to include their direction, distance, speed, the VMG, the air temperature, the water speed, everything you could possibly want. Third, we have reports from different news organizations that paid to have their planes fly out and take pictures of these boats as they sailed past their shores. Then, of course, we have the ships that crashed, such as I already mentioned, the Hugo Boss, and had to crash out and go to dry dock. So we have those boats in dry dock.
Yeah, I'm interested in how. Okay, so I guess if it's done by GPS, if that's what you're relying on for your distance, I'm probably
that was one of the ways. We're also measuring our speed with through-hole sensors and celestial navigation, and the fact that all of them co-confirm each other. That's not the right word, but
corroborate.
Thank you, Bao. They corroborate each other, gives us a accurate position on the map.
Okay. Well, I'd like to see more details on that. So this is the route that I'm showing on here, the 2020, 2021 edition.
Let me get you a little bit better map.
Okay.
I'm posting it in your general chat right now. This one is cool because it has a little red line. If you hover over that line and you scroll back, you can scroll through the entire race and then hover over any of the boats at 5-minute increments, get their exact information.
Okay. I don't see the link yet. Did you post it or?
Oh my God, I posted in the wrong server. I'm sorry. Let me try that again, sir. I apologize.
Oh, fuck. You're going to get banned now.
I know.
All right, here we go. Let's see what we got going on here. Okay, so here's our boat race. Oh man, it's probably some spyware or some shit tonight. Come on. All right, so you said I could zoom out.
You can zoom out, and that red bar at the very bottom. Kind of think of this like a YouTube video that will show you the race in real time.
Okay.
Yeah, but this tracker is on a 2D Earth though.
It is, with major perspective issues.
What a fucking long time.
So if you click on the globe, it'll make it a globe. Showing the essentially on the right hand side of the screen.
It's very cheeky about it.
It'll make it a cube too.
Don't believe there is. That'd be kind of cool to see.
What did you measure based on this data that you think falsifies flat plane?
Also, it's the time that it took for them to go around.
Right.
Also, you can click on each vessel, and it gives you tons of data.
It's going to give you a lot of data, and just to clear it up, the important piece is the VMG. That is their velocity made good. It is the aggregate of all those numbers. It is their, basically think of it as their speed if they pointed in a straight line.
Okay, but which part of the route and, what do you think falsifies the flat plane? You think just because they went here and then here, like this distance, are you measuring, or are you measuring the whole length, or what are you measuring?
Because if you look at a globe Earth and you see the distances that would be predicted or proportions, and then you look at something like an AE map, it would be vastly different on the time that it would take at the speeds they're going.
I get the
And what's
concept.
the
I really
proportions are off.
do. But you're not giving me much here other than they would need to go faster on this AE map. You haven't
Right,
given
hell
me
of a
enough to
lot
falsify
faster.
anything in my mind yet.
A hell of a lot faster,
Well, yeah, of course
Brandon.
not.
Come
Yeah.
on.
Oh, that yeah.
Yeah, they-
Okay, you're saying that. Describe to me. Are you talking about this part? Are you talking about the entire circuit? What are you talking about?
The entire race.
Okay, so
The
then it
entire
goes up
race.
in here and it comes back down. So did you count that part right here?
Yes.
The entire race.
Okay.
So this is a solo race. One person gets on the boat in France. They then don't touch land again until they step off in France. The winner did this in just over 80 days.
Do you have a comparison between the globe distance, your calculated globe distance, and what you calculated on another model?
I think Tommy Gronville did a really good video about it.
Yeah.
It'll more than likely, it'll take a known distance that we probably don't argue about, and then use that same proportion to match how many of those proportions on an AE map it would be, and then extrapolate a distance. That would probably be the best way for a flat Earth.
I think on
prediction.
an AE map would be
So
roughly
start measuring it against something
7,000
that
miles.
nobody's made a claim on.
Right.
The thing that I
Like, what
measured
is
it
going
was
on here?
was the
What
known.
tools did you use? Is that all you've got? Is the distance travelled? Well, distances are distances. You can travel on a boat on a flat plane. You know that's ridiculous. We don't. You know, you haven't got a map to compare it to.
We have
so
a map.
what tools
You don't have a
are
map.
you using?
We have a map. You don't have a map, but we're trying to provide a map to you using logic.
What tools are you using?
What,
on
like
this boat?
speed and time?
Yeah,
Speed and time?
for your measurements. What are you using to navigate?
They used a combination of things, including stellar navigation, solar navigation, dead reckoning, GPS, known
Solar
wind
navigation.
locations. Yes.
Celestial navigation.
Yes.
GPS, that kind of thing.
Yes.
Yep.
So
Dead
what tool
reckoning,
do you use?
landmarks.
Yeah, okay. Okay, so what tool do you
Yeah, Science is Science, $5. Dr. Zach's data showed the sun's pattern is a toroidal field when mapped out. Yeah, I gotta look at Dr. Zach's latest video. I haven't seen any if he's put anything out lately. Last I saw was his video on the Polaris, I guess, challenge to flat earthers. So I don't know if he's done anything. Thank you very much, Science is Science.
should be able to explain how a sextant works. Asking that
Do you want-
question
do you
gets
want me to
me
explain
told,
it to you?
I don't know how it works. Well, I've just asked him.
Because
So,
you're asking the question. You're asking
and
the
instead
question.
of you letting him answer, you're now carrying on like a child.
So you're
Why
asking the
is
question.
that,
if you do know
Biojoule?
That's 8-ball.
Why is that? Maybe because you know you need to have 3 flat circular planes underneath your 3 stars to do your triangulation.
So do you-
Maybe
okay,
that's
so
why you're
listen-
trying to stop me
Okay,
asking him.
Can I address this? I mean, honestly, do you
No.
know how it works?
No, you can't, because
Okay.
I was asking the other man, the lovely man who was talking very nicely. I was asking him, not you. So if he would
Okay,
like to
Miles,
explain
if
to me
you
how
wanna
he
answer
thinks
that.
a sextant works, I would
I know it.
appreciate it.
Probably doesn't know how it works. So go ahead, Baldo, you can answer.
Shut up, 8-ball.
No, I would like the man who says he's the sailboat expert who came in with the positive claim. I would like him to answer, please.
Yeah, it's not a super complicated thing, but it will take like over an hour to fully explain to you. I would direct.
No, it won't.
I've heard it explained in less than 30 seconds, mate. So I'm sorry, but
Okay,
you're wrong.
the-
It's very,
the basic-
very simple to explain.
The basics is you are measuring the angle from your solar or stellar observation to the horizon and confirming that with your time to give you your latitude.
Right.
That's the
Right.
most
when you
basic,
take that
but
angle,
it gets more complicated.
when you take that angle, yes, so yes, that is, yeah, perfect. When you take that angle, the line of sight from your eyes out to the horizon, the star's geographic point is not at that horizon. It is however far, it could be 1,000 miles, whatever, however far away it is. But that straight line that you draw out, yeah, you're making an angle, 2 straight lines. So you're drawing a straight line from your eye out to the horizon, but it's only stopping at the horizon because that's where your eyesight stops. The line actually keeps going all the way to the underneath of the address, the position on Earth that the star would be directly above, right? So when you get to that point, yes, because then you have to make a 90-degree straight up to the star. So yes,
that's wrong. That's incorrect.
This is how you make your triangle.
No, all we're doing is making an angle from the horizon to the star. That's it. Has nothing to do with the distance to the star or anything. It's just an angle.
Yeah, a straight line, 2 straight lines.
Yes, a straight line from your eye to the horizon. Yes.
Yeah.
We're not concerned with anything beyond the horizon.
Line.
No, we're not concerned with anything beyond the horizon. It's just the line from your eye to the horizon.
Can you stop, BioJule? I'm not talking to you.
No, that's 8 Ball.
So
you can't make a straight line to the horizon.
Yeah, you guys can't make a straight line. If you were to draw the line out from your eyesight over the curve of the ball, your position on the ground that's directly underneath that star is now not on the same.
That's not what we're concerned with. This is why I said you
it is.
No, it's not.
That's how you do. It is. That's how you do. It is.
No, it's not. You're incorrect.
I didn't catch your name, but I'm sorry. You're not correct. That's not what we're concerned with when we use the sextant.
An angle's not 2 straight lines.
An angle is indeed 2 straight lines intersecting.
You don't have one.
Okay. You can say that, and I respect your opinion to say that. May I recommend a couple of...
Can you understand that if your line is curved and you are saying it's straight, those 2 lines would end up in different positions? You understand that, right? Like the line out from your eye, if it's a straight line, will end up out on a ball. It will end up out in space. But your line curves around the ball. So those 2 end points.
Wait, my line's not curving around anything.
You?
Yes, and
you
I'm
live
drawing
on a
a
ball,
straight
don't
line.
You?
Yes, and I'm drawing a straight line from my ship to
you
the horizon.
You can't on a ball. No.
Why not?
You've got to, because it's curved. The ground's curved on your ball.
But
you can only draw a straight line if that ground
the visual
is
horizon is the visual horizon is a thing. We can point at it. We can draw a straight line from our position to it.
You can't. No, you can't.
Why?
No.
What?
Because you live on a globe.
Okay. I respect your opinion. Please go look at
Dude, 8 inches per mile squared drop from the observer in all directions. Your model, not mine.
Yeah, you want to see something else that works on our model?
A straight line. You cannot have a straight line out from your feet. It drops at 8 inches per mile squared. So why are you telling me, yeah, I draw a straight line?
Line of sight, Paige. Line of sight, Paige.
Yeah, and on your ball, that's curving.
Yeah, but it's not measuring from his feet, does he? He measures from his eye.
You're acting like we see in straight lines now. So when we go down to the black line... go ahead, Paige.
Sorry, you're still drawing the line around the edge, like you're going around the ball and then out to the star. So on a ball, that point on the ground and where the star is are going to be in 2 totally different places. If one line's straight out and one line... Yeah, no, dark, because we're on a flat plane and everybody just looks up.
This is how I know you don't know stellar navigation, because the correct way to attack stellar navigation was your meassurement
Don't
taking...
tell her what she doesn't know. Tell her
Hold
what
on. Hold on.
Okay,
I'm about
Yeah,
to
I
get,
asked him to
I'm
explain. He
about to
won't.
get to it.
He just wants
The
to
part-
belittle me.
The part you want to attack and the part that actually has a little wiggle room is for stellar navigation. We use our
Don't
deck
tell me
height.
what I should attack. Okay, I know you have to take yourself back down to the height of the water. I understand that. That's
No,
not the point.
you
The
don't.
point
We
is
don't do
you're
that.
making an angle. You need two straight lines. You don't have them.
Okay.
You have a
appreciate-
model that drops at 8 inches per mile squared,
on your model,
dude.
on your
So
model,
what does it do?
wrapping
Does
around the
it
ball,
drop?
It's going to change the angle anyway.
Does it drop at 8 inches per mile squared, or can I draw that line straight out as a straight line all the way to underneath the star? Which one is it?
Every 69 degrees, their shit's is angling. Every 69 miles, it's angling 1 degree. So if they're looking off of the star,
Exactly, Brian.
Supposed to be like 1,000 miles, then it's like whatever umpteen amount of degrees. It's not going to line up. If she is 100% correct, we've already
Yeah.
you know,
Yeah.
It's every 60 nautical miles. 60, not 69. 60.
yeah, 60 nautical miles. And,
Yeah, 69 on the land. So yes, you're both correct.
it's like
Why is it different,
69 miles.
nautical miles versus statute miles?
Supposed to
Why is the
Supposed to be
difference?
like 2.2 miles or 2 miles or some shit
It
like
was
that.
because sailors lacked the reference point that they used on the ground, so we had to use stellar navigation in order to create a statute.
That's interesting.
It's actually
Brandon,
it's a really interesting history coming out of Spain, I believe.
Yeah, I asked that question the other day. Why do we have different measurements for land versus air versus water? It's kind of ignorant, right?
it's to confuse people. A baller sent 10th Man a diagram of how he says a sextant worked, and it was just brilliant because the circles he drew underneath the stars, like he's drawn a ball, drawn him on the top of the ball, a star on the left, a star on the right, lines down from the star to the ball, where he's then drawn a circle around the spot on the ball, and he's drawn
Right.
the radius through these circles as a straight line. So flat circles.
Yeah, they
under all
always
these
pretend
stars.
that they're standing on a flat surface whenever they
Yeah,
do these
unbelievable.
measurements. Pretty funny.
How could
Anyway,
anything even be that close to accurate at that point?
Here's the thing. Regardless of all the holes we poke in it, stellar navigation works.
yeah,
It has
no
worked for
doubt, it
thousands
would
of
work on
years.
either model.
Pretend you're
Yeah,
on
it
a flat
worked long
surface.
before
It
the
works
globe
on
was
air.
around.
It doesn't. Congratulations.
Hold on, it worked before you had a sextant, son.
It
It
worked
did.
before they
You're
thought
right.
the Earth was a ball.
Welcome
Wrong.
to
Yeah, it
Flat
worked
Earth,
did
sir.
long
not.
before the globe
Yes, it
Earth
did. The
was
Mayans
around.
were excellent sailors, and they believed in a flat
They
Earth
were.
model.
They did
Yeah.
not, sir.
They did.
They worship
That's why they
a
The
discovered
Mayans'
Europe, right?
cosmology, you
And-
can look
and
up
they
the
were
Mayans' cosmology, dude.
World-renowned
It's
astronomers.
Viking.
So how do you square that the Mayans, these world-renowned astronomers, had a flat Earth model and could chart the stars so accurately? It's still accurate today.
So I talk sailboats. You want to talk about sailboats? Let's talk about sailboats.
Yeah. So here,
Oh my-
wait, hold on. Yes, I do want to talk about sailboats, but the subject
Okay.
came up, and all I said was a very
Of the
benign
Mayans,
statement that
who cares?
you could navigate by the stars on either model, and you didn't seem to like
Which we
that
couldn't.
statement. Why?
Right. Because in order to get 60 nautical miles, you have to have Polaris drop.
Oh my God.
It
Okay.
wouldn't do that.
So what does it drop off the distance?
Hold on. Let me explain myself. Let me explain myself. Let me explain myself. So here's why I say it would work on either model. All you're doing is observing the differences in the height, alignment, position of stars, and you're correlating that to a certain amount of movement in one direction or the other. Once you chart that and understand the basic relationships, it doesn't matter what surface you're on. You'll know if the star moves this much, if it's there, that means I'm this far away from this spot. It's all about correlating what you're visually seeing and the relationships between what you see and where you are. Very
that's
simple.
incorrect because it would be very
It's 100%
different.
correct. I said a very benign
No, it would be
statement.
very different. It would be very different on a flat surface because things in the sky wouldn't drop at the same rate they would on a curved surface.
It'd be very different on a
Guess
globe.
what? We're on a flat fucking surface right now, and they
No,
drop
we're
how they
not.
drop, and you have convinced yourself,
So
as the rest of the world has, that we're on a
You
ball.
are not allowing.
So I know you're
for
wrong.
That 69 degrees, that 1 degree drop for every 69, 60 miles. You're not allowing for that when you draw the straight line, because you're not drawing the line that's dropping to cause that 1 degree of change. You're not drawing that line. You're drawing a fucking straight one. Like,
See,
honestly,
I
guys,
don't think
this is
I don't
beyond
no,
ridiculous.
no, just because you don't understand the relationship between things in the sky and a curved surface. If you understood this, you would understand the argument.
You know
right?
what I get really sick of? I get really fucking sick of us being told what we don't understand.
Let me. Can I say something really quick? Let me think about this.
If you say
So,
you
okay,
don't
you're looking down
understand one more fucking time, Earth is life.
I mean, okay.
You said it
So
3
think about
times in that goddamn sentence.
Think about this. Can I explain something? Think about this.
Are you going to actually
You're looking
explain
down
something?
a hallway, right? You're looking down a hallway, and you got lines on the ceiling. The farther you look down, the closer those lines are going to look.
A flat hallway
Right?
or a curved hallway?
No, a flat hallway. You're looking at a ceiling. The farther you look down that hallway, the closer those lines are going to be. Now, draw an angle to each of those lines, and the farther away you get, those angles are going to be smaller and smaller and smaller.
Now
Depends
curve
on
the
how
floor.
high the roof is. Yeah, but yeah, it'll always. Name me something that doesn't drop in the distance, bro. Why should stars be any different than anything else in reality?
Now, hold on. Now, do it on a curved surface, right? And you'll see that every single time you take an angle to a fixed point over a curved surface, those angles are going to be even every single time.
That relationship that you just talked
that's
about,
what
that relationship that you just talked about can be gained on a flat surface, just so you know.
No.
It can
No.
actually.
Over
See,
a
you didn't
curved
talk, you
surface,
know
those
how I
angles are
know,
gonna be
you know how
even.
I know that you haven't thought it through? Because you haven't
Oh,
even
trust
thought
me, I
about
thought.
how
I've
the
made
height
several-
of the object impacts
I've made
that
several videos
relationship,
about
have you?
I've made several videos about this, going into this extensively.
Well, you need to think about it some more, because there's some variables that you're leaving out.
One
of them,
variables are
namely the height of the object above you, and second, and you're going to puke on this, the finite vanishing point that we have in our reality.
the vanish, that would be a hell of a lot farther though.
Yeah, it would. Yeah.
The distance, so the distance of the star is irrelevant. I hope you know that.
The distance to the star
It's
is
irrelevant.
I know you
Yes.
guys want to make it irrelevant. That's why you put them out billions and
irrelevant.
trillions of miles further than we could ever fucking possibly hope to go.
And they
The
also
nearest
move.
star is quadrillion miles.
Well, they move, do they? That's why they're in the same fucking place all the time for thousands of years.
But that's not true, sir.
How much has Polaris moved in the last 2,000 years?
Yeah,
Polar-
what were the
hold on.
constellations? Mine.
Go find it. Go look it up. You tell us all how the constellations have changed over the last 2,000 years. You go tell us.
How come the handle of the Big Dipper still lines up with the pyramids? I mean, so
Y'all aren't letting him answer.
they didn't think that through with the pyramids, did they? You didn't think that answer through.
No, they planned ahead, Brian. You don't understand.
Explanation just a little while ago.
They planned ahead. They offset the fucking pyramids to line up with the stars the way we see them today.
They chose the brightest stars in the sky because they're the most noticeable and they're also the closest. But irrelevant to that,
The closest
nautical
ones would have
shipping-
the most parallax, and we would see the movement more. Silly.
nautical shipping charts require it to be updated. It is illegal to take a sailboat out with charts that are over 3 years old because the stars' positions have changed enough that your calculations will be wrong.
It's illegal. They have to put a
buddy.
disclaimer on the globe because if you try to navigate with it, it doesn't fucking work, dude. Listen.
Well, what about that? What about it's illegal
It's in
to
our
take
written
stars?
history, bro.
Hang on, has he ever checked that? Has he ever actually gone back and checked on
Why
those
is it a thing?
charts?
Why is it even a thing?
Christopher Columbus was the first one to
Yeah,
try
well,
and
there's a
navigate
lot of
with
things
globe.
that happen these
He
days
wound
that
up in
don't
South
need
America.
to be a thing, but they are.
Yeah, the
lo-
stars
lots
aren't
of
changing
laws are
that
made
much.
not
They're
for
not
the
like
reasons they
moving.
say they're made for. Pretty
They're
sure.
not moving around like that. Give me a fucking break.
You're right, and I think the law is a little too restrictive because the change isn't enough that 3 years makes a difference. However, if I was to go pick up one of the charts from the 1500s, which still exist, those charts are extremely wrong.
Really? Have you done that?
Yeah, because the stars are moving. Oh my goodness.
Oh,
The sky, that doesn't
You
say
just say yes.
anything
You
about
just
the
say yes,
ground.
you've done it. Please
Yes, that would have been
demonstrate
correct.
this to us.
I'm sorry, I was in high school. I don't have video of it.
Brandon,
So
we're donkeys
you had
arguing again,
access
but we're arguing
to
with donkeys.
star charts from 1500 years ago in high school that you confirmed and went out and verified that the stars had moved away from where those charts say they were.
Not
in high
1500 years ago, the 1500s. Yes, I did because I was doing correspondence from a sailboat.
Hey, Brandon,
So
they
going to a
offset
sailing
Brandon, they
museum
offset
was
the hole in
something
the
we
Georgia
did.
Guidestones too, man. They offset that little hole that real tiny little hole that you see Polaris through. They offset
Been around for
that.
30 years.
So guess what? It won't be lined up. It won't be lined up in about 50 years. It'll be misaligned, man. They'll have to drill a new hole through it. Fucking retards, man.
Anyway, guys, so if we can't get past the point that celestial navigation would work on a
No, it
flat
wouldn't,
surface as well as a globe surface, I don't think we're going to get anywhere because it's plainly obvious that you're just charting the changes in what you see in the sky. That's all you're doing and correlating it to the ground. This is not a hard concept to understand at all.
Right.
No, I mean, I think you guys are missing it. You're really missing it.
No, we're not.
Well, let me ask a question.
I think you
real
might
quick.
be missing critical thinking skills.
We're
Yeah, let's-
also
okay,
getting
real quick.
bogged
Hold
down.
on, one second. So Polaris will drop, right? On
Hold
a
on,
flat
just
Earth.
real
Yes,
quick. Let's go back.
Bro, Polaris didn't drop. They fall. Look in the Bible, bro.
Yeah,
They
you
followed
say-
the
yeah,
Polaris
yeah, you
star
say
to get
that.
to Jerusalem.
One
You
second,
fucking retard.
will
Hold
not
on.
drop at the same rate on a flat surface.
Bullshit. Like I said, you're leaving some variables out. You don't know what the fuck you're talking about.
I know exactly what I'm
Travis, the
talking
plain
about.
truth. Go ahead.
Yeah, it's just real quick. You know, the update every 3 years. Do you have to pay for that, or is that a free update?
It comes with your chart subscription.
Okay, so you have to pay for the update.
To be honest, last time I was on a boat, the charts were updated a lot more often than that because shoaling's a thing.
This is a non-answer. This is a non-answer.
skirting his point.
Okay, hold on. Is a
we paid
subscription? Okay,
we paid a subscription fee.
That's the fuck why they make you update it every 3 years so that they can take your money that you don't need to update. Okay,
But
so look,
you
no,
missed the part where we're updating every 3 months because shoaling is a thing and we needed the updated shoals.
Okay, again.
Yeah, but that's not updated star position.
Right.
Yes, it was. It
Right.
was a full update.
So shoaling affects the stars. No, listen, just very carefully. This is the reason why the whole system is controlled. All right, this is why you got to do your registration. This is why you got to do your license. This is why you got to do your smog emissions. It's all to just continue to take your money for shit that you don't actually have to update. Now, listen, all you have to do, find somebody who's got 50-year-old star charts, stick them out on the water with you in your updated thing, say, let's go to this place and see who can get there the fastest. Both of you are going to get there. Just depends on how fast the one gets there before the other. But you're both going to get there, and the other one doesn't need an updated star chart.
Hey, are these star chart changes, do they have anything to do with the time of day? Are they time correlated? The time of year that you would see certain stars?
Yeah.
Do those tell you that?
Yeah.
Because that changes, obviously. That
Right,
pattern
and
changes. We know that. That
Not
changes
all
faster,
stars.
but
3 months.
yeah, hold on. The relationship between the stars and the constellations, which is what we're concerned about, doesn't change. The star patterns underlying the constellations wouldn't have changed very much over the last 10,000 years.
No.
You don't need to update your book because the stars are moving apart from each other or in relation to each other. It's because the entire constellations are shifting due to the change in seasons and the celestial cycle.
It's like
That's why
looking
you
at a big
needed the
clock
updated
in the
fucking
sky.
charts.
Right. and this is why our
the
charts
sky is
are.
actually moving.
That has nothing to do
Got
with
nothing
either
to do with
model.
Here's the thing where we're getting away from.
Equinoxes.
We are. I will. We will.
That's a thing.
We are getting away from the fact that the star charts work, celestial navigation works. These boats went the distance they said they went according to star charts and celestial navigation. However,
You haven't offered
40,000
any evidence about how far they went in relation to how far they should have gone, correlated to any maps, shown any.
But
You've
he's given
shown no
no reason why
falsification.
they
Hold on,
could not
hold
work
on,
on a
guys.
flat
Fuck,
plane.
man. You showed no falsification of anything.
Honestly, this is worse than his
Can I
450-foot
No.
long pole or whatever
Can
he
I
had in
have
the
it?
water.
Can I have
They had an app called Planetarium, and
Hey guys,
it went
can I
back
ask?
5,000
Can I
years
respond?
and forward 5,000 years, and the stars reset 5,000 years. And you know what they did? They took down the app where it only goes 500 years in the future now because it fucking didn't change. The North Star didn't change. Nothing
Yeah,
changed. in 5,000
Jeranism did
years.
that, yeah.
Yeah,
Yeah.
it's fucking hilarious. So what do they do instead of trying to? They take the fucking app down. Same thing they did with Bob Wins, the nullschool.net with all the wins. Because if you look at it, you see that it's a stationary plane. All the winds.
Oh, it was
makes the
beautiful.
ocean current,
That null school map
the
was
ocean
beautiful, yeah.
temperatures. So they had to
Yeah,
take
it's
that
funny
down because
when we
anybody
go-
with common sense can see that it's not a fucking globe. The model looks retarded on the globe. They asked for flat Earth models. We show it to them. They eliminate it off the fucking internet.
If
They're
he
dishonest.
wants a flat Earth model, go to a planetarium. Go and there's my working flat Earth model. Go into a planetarium.
You can
What is
walk
your
around-
response? Go
Can you
ahead
do
and
that
respond,
for me on a
Kool-Aid.
globe, please.
Kool-Aid, you wanted to
So-
respond. Go ahead.
Yeah. Shit, I'm
There?
sorry. That was a lot that just got thrown at me. I apologize. Go on. I'm gonna need a moment to absorb.
Okay. Okay, no problem. Anyway, guys, so yeah. I would of course be curious to see these maps and how you've correlated this trip on the supposed flat Earth map and the supposed globe map.
Sure. Which map should I use? What?
Good question.
What
See,
should
we
I
don't
put
we
it?
don't know what the real
Do it
map
on
is
every
because of
map
all the
you can
fuckers.
find.
We don't know. You said you falsified something, so I want to see your evidence
I
that you have
falsified the
falsified
A-
something.
The AE map cannot possibly work.
Oh,
That's a
well.
globe, dumbass.
The globe
Doesn't
is
the
a
AE map
fucking-
already say
You
that
just
it's
falsified
self
the globe.
because it's just a
It's
globe
fucking
projected?
map wrapped around a globe.
The AE
It's a
doesn't claim to
projection.
be true, does it?
Be more specific. You're Kool-Aid. You're ignoring the longitudinal distortion that's involved on the AE map, right?
Right. Yes.
There you go.
Ignoring the distortion and using that as presented as a flat Earth map. That
What map
map
do you think they
globe
use
for
to
a
navigate
flat.
with? You
So
think
if
they have
you
a
use
globe
a globe
sitting
and
on their
project it,
desk?
it doesn't seem to work out good. Okay.
No, it works out good when you
Use
account
a
for the
globe and
distortion.
figure out it doesn't work as a flat.
No, so
Duh.
the AE map includes distortion of a spherical Earth. So when you can use the AE map, but you have to be mindful of the distortions that are present.
The distortions
No,
get when
the
you get
globe
down-
is
when
the
you follow-
distortion. The globe is
When
the
you-
distortion.
As
when you
claimed,
follow-
but not when you apply it to reality.
No,
when you
actually, in
follow the
reality, the
map-
globe is a distortion of reality.
No,
That's why when you map it back and try to make a flat map from your fucking globe, it's impossible to correlate to anything because it's nonsense.
It's not impossible.
Two
You
tiers
require
removed from
distortion.
reality.
No, you require distortion because the surface of a sphere can't one-to-one
What
be shown
use
on a
does
2D
it do
plane.
me to map a distortion onto another distortion?
Because as long as you're mindful of the distortion and aware of what's being distorted, you can navigate it quite precisely.
Yeah, as
You don't
long
even
as
know
you
what the
accept the story
distortion
you've been
is.
told about where to do the numbers and everything
You
like
can
that.
see where the
well,
distortion
then
is,
you can
the
get the
shapes of
exact
the
answer you need to
longitude
get,
lines.
right?
You got
You could
two
also
choices
follow the
with it.
math that's on the AE globe or the AE projection map, which puts the Tropic of Cancer and Capricorn being roughly the same size, and also the Antarctic and Arctic circles being roughly the same size, forming a
It's
sphere.
azimuthal equidistant, so you got to equalize the azimuths, bro. Okay?
And when you do that, you form it back into a sphere. The
And then when
sailboat
you put
rates
it on a
work.
flat map, it's distorted, like Brandon said. Are you deaf, dude?
Yeah, that's just a consequence of geometry.
Right.
It's not a consequence of what is the Earth's shape. That's a consequence of geometry, putting
Y'all keep
the surface of a
about the
sphere
map.
on a
The
2D
AE
plane.
map is a globe, okay? Basically, AE, the azimuthal equidistance. So the Capricorn is the same distance as Cancer. That's what they mean by azimuthal equidistance. You got to adjust the azimuths. They're equal distance, okay? So when you say that it don't work, you're shitting on your own globe. You fucking retard.
No,
Big
because
time.
he's not accounting for the distortion.
It's a
And when I
huge
did account
steaming
for
pile
the
of shit on
distortion,
the
it
globe.
did work. That's what I, and thank you, Biodu, for correcting me.
It'd be pedantic.
When I did not correct for that, it did not work, and I ended up with 40,000 additional nautical miles. When I did correct for that,
when they tried to navigate
when
with the
I-
globe, they even said it. Christopher Columbus set out. He wound up almost in South America. He wound up in Central America. He thought he was in India. You cannot navigate with globes. It doesn't work,
Yes,
bro.
yes, you can.
No, it does
Nope.
not work. That's why they have
The
displays
chart
on
program-
every globe.
Brian, if I get lost trying to drive somewhere, does that place not exist? Does my car not work?
talking about
Does my
crossing
navigational
oceans, bro.
equipment not work?
Take your globe and try and cross an ocean, and you will not wind up where you're
Yeah.
supposed to.
Yeah, I will. What I'll do is
My-
I'll
You
just
won't,
go
bro. You
east.
got to use the stars, which is
My
flat
chart program
triangulation,
is a
bro.
globe.
Y'all are literally trying not to hear what we're saying. We're telling you
No,
about
Brian, you're
angle
saying
and how
some
there's
retarded
straight
shit.
lines.
Though. That's the thing.
Or a state
Retarded
globe
shit.
map
It's
to get
fucking reality, bro. An angle is two
Use
straight
the city
lines.
globe map.
What is retarded about that? Are
Straight
you
globe
kidding
map.
me?
City globe
I don't know
map.
why you're trying to change the subject or obfuscate, unless
State
I
globe
missed that
map.
part. But you know,
State globe map, block globe map, city globe map. Use one of those, buddy.
it's just so strange that you keep saying that it doesn't work or you can't use it, despite so many people currently
I'm gonna say
using
one
it.
more thing. I'm gonna try and touch your common sense. Okay. Now, common sense. Go to Google Maps, and common sense. When you get up to 30,000 feet, that's what you would see. If the Earth were a globe, it would curve like it shows in the computer simulation. However, it doesn't curve like that. That's what it would show us if we were on a globe when you go up. Okay. It's just not reality, bud. Okay. Does that touch to your common sense?
Here's the common sense. Here's common sense, Leaky. Do you deny that pilots, professional pilots, commercial, military, private, however, are using flight charts based on a globe map with
Yeah,
headings?
so they see a flat horizon and they're like, "Where's
No,
the
no,
curve?"
Brian. Let's stick to it. Let's stick to it one by
Hey,
one.
the curve is always just a little bit further, Bo.
No, I know you want to
Where's
change the
curve?
subject,
Just a
but
little bit further.
you want to talk about common sense. Professionals are using flight charts that are spherical in nature, those maps, because the headings are required to be used on a sphere Earth. Now, common sense would tell me if the professionals are using it to ensure safe travels all over the world at all times, what do you think common sense tells you then, Brian?
Google Earth is a flat Earth model, bro. You look at
There you
the
go. You
elevation
can't even address my question.
It's, dude, anybody can address it. It's like talking to a fucking donkey, dude. You don't listen to
Where's
nothing
your
we
city
say,
globe
bro.
map? And the state globe map. That's what I want to see. Your highway state globe map and your highway city globe map and your streets and your stuff like that, like on the
Yeah,
globe.
they want curveless curves. That's all they want is curveless curve. They're fucking retards, bro. I'm sorry. Nothing personal.
Honestly, I'll bet the continents don't even look the way they do on the globe. I'll bet you in reality, it's all fucking different.
I told you, I know Florida doesn't.
If only we
Because
had pictures
Florida-
from
across
satellites that
Florida,
could
everywhere
show you the whole
available.
continent.
It's not- it's different.
Yeah, we don't.
Listen, just real quick. So, how far back do we have to go before they weren't using what you would consider a globe projection or GPS? Let's go back to 1942. Let's say maybe December 7th, when Japan came all the way across the Pacific. What maps were they using?
I don't know, man. I didn't exist in 1942, and I'm not
So
Japanese.
do you think that they were using GPS or globe projections? Or
No, they're probably using globe maps, but not GPS. That might be my suspicion.
Right. So again, when we go back, as far as we can go back, before they switched over to a different system that you consider globe model, it's going to be celestial.
Right. I have no problem with that. Sure. Is that a mystery to anybody?
Before their gyroscopes had pendulous vanes and all, and guess
Is
what?
that a mystery to anybody that they use the stars to navigate?
No, it's fine.
Not a mystery to me.
But when you use those stars and then you look at those stars and you think the relationships and what you're seeing is because you're standing on a globe, and then you pull those stars down and you correlate those to the surface that you're standing on. When you make that assumption, you fuck everything up.
Yes. Right. So on a flat Earth and a spherical Earth, the measurements to particular stars at a particular location will be vastly different. That's just another tool to use of if sphere, then this, if flat, then this. Now we check reality. Blah.
No, they're not. If you have two people that are standing on the ground and both of them have they're both going to get the same measurements.
Depending on where they're at on the Earth.
Well, that's a given. That's a qualification without distinction.
No.
Of course. I'm saying if you have two people, right? Okay, so then have them switch locations. Put a flat earther at 36 degrees and whatever, and put a globe earther at 77 degrees and whatever, and then switch them. They're going to get the same measurements, and one's going to be a flat earther.
Yeah, for sure. But there's a relationship. There's a relationship between the viewing angles of the same celestial bodies at different locations on the Earth. There's a relationship with that and the shape.
No, that's only after you impose the globe model.
No. You can impose any shape you want, but it works consistently with the sphere.
Listen, when you're standing on the ground or when you're on the deck of a ship on the water, you're not imposing anything but a sextant and angles. Okay? It's just what Brandon said. You guys take the arc of the sky and then bring it down to the ground and then fabricate or project an arc onto the ground and call it 69 miles.
Yeah, it's inverted.
That's all
that
you guys
video
are
I
fucking
put
doing.
up.
It's a fun claim, but you have no evidence for that.
We do, but
It's not a fun claim.
That's what
How
I
do
meant
you
when I
get?
said, where's the curve? Just a little
Yeah,
further.
how do you get curvature on the ground? Where does it come from? You don't know.
Oh, you can get it from a number of different places, different methodologies. When we were talking about the stars and navigation, that was just one methodology.
No. The stars and navigation have to do with angles to the sky, not the fucking
Right,
ground.
and there's
So
a
now,
relationship.
take us down
There's a
to the ground.
relationship to
That's how
those
they made
angles
their map
with the
of the
shape of
sky.
the Earth.
They
Whatever,
made their map with the stars and the sun and shit. So that's
the
what's
shape
gonna
of
match.
the shape of the Earth will have a relationship between what those angles are at different locations. That's the entire point here. I understand that there's angles to stars. I understand that part.
No.
But what you're not understanding is that if you're on a flat plane, if you're on a flat plane or a sphere Earth, you're gonna have different angles.
Say I don't understand.
You don't understand. You don't
say
understand, and
I
I'm trying to say it, but you keep interrupting, so you know you won't listen.
On the ground,
If you don't listen, it's easy to misunderstand. You're right.
On the ground, your position on the ground is going to be the only thing that changes the degree of the angle to the star that you're observing. That's it.
The shape of the ground will also have a relationship
you
with that.
have to make your assumptions about the stars.
You
the
don't have to make any
distance,
fucking
how
assumptions. You just
optics
make
works.
measurements.
Elevation.
No.
I've never understood this. You're making measurements.
Elevation. Yeah. So great. Now we're back to the measurement part. So now we're on the Earth. Now tell us how you find the curve when you're standing on the ground, my friend. Go ahead.
What, using the celestial navigation?
Yeah, you don't know
What the
anything.
fuck?
You're standing on the ground, you see the stars. You've got a sextant. How do you determine what the shape of the ground is below you?
Oh, I don't know how to use a sextant, but I understand the angular values to different things at different latitudes, namely Polaris, and then your
So he
angular
spent all
viewing.
that time telling me I was wrong, and
Oh, I didn't
now
say
he
shit
says
about
he doesn't
sextant.
even know.
He doesn't even know how a sextant works.
Yeah, I never
Probably
spoke to
Probably what
anybody
you're
about
saying
a
is you
sextant.
know what the globe model is and you know what it's supposed to work like on the globe model. You don't know how to do the thing in
thinks I'm
reality.
you. I
Yeah,
apologize
probably.
for that.
No, that's fine. We have similar voices, I guess. But no. What I'm talking about is the particular angle that
the
you would
two
have
of
to
you.
Polaris. The particular angle to Polaris from each person on Earth, and then measuring the distance between those observers, and you can come up with a distance and shape required for those distances. So I measure an angle, I measure a distance to someone else who has an angle. What shape Earth would fit these numbers? It's only a
There's no
sphere.
fucking shape. It's called
Yeah, so he
distance,
just
you dick.
comes up
Yeah, I
for
know,
something. You
but
just
those
imagine
distance and those
something.
angles can only work
Even
if the
though
surface
he's
is
using
curved.
angles
No.
with
No,
two
that's
straight
not
lines.
true.
My
That's
Oh, no?
God.
absolutely
Okay.
not fucking true.
No, it is true. It's 100% true. It's
It's
verifiable.
not.
Oh, but it's
It's
not.
not
It's 100%
bio.
not true.
It isn't true.
No, it is. No, I'm playing PUBG, so I'll have to verify in a second. But yes, that is 100%
Bio,
true.
go
If
stick your
there are
head
two
back in the
observers,
Where are you
sand,
going to
you have two-
verify
Go
that?
away.
this is essentially triangulation, where you have two observers and you have measured angles to something. You have a known distance between each other. You can come up with these calculations, and the only way this works, and it breaks down with more observers. The only way this
Bio,
works
you
is
need
if
to go
the
and
surface
watch
is
10th
curved.
Man's presentation.
Paige, I'm not going to
on
watch other
Nathan.
people's
It's
dumbass videos.
very
If you
quick.
can't articulate a position, then
Yeah,
that's it.
you don't want to teach yourself. That's the problem.
I don't want to watch random ass videos. I
You
want
have
people
just
to
expressed
articulate
to
it.
everybody here that you are not interested in actually learning by
No,
saying
no,
that.
I'm here to
Well
articulate
done.
with people.
Well
If you want me to
done.
watch videos, then
Well
don't have a
done. You
Discord.
don't know how they work. You admit it, and you'll not even go
Oh,
and
yeah,
teach
sextant.
yourself. You want to live in ignorance.
No, I don't require a sextant. I don't require that within my argument.
Sextants will only work on a flat plane. It'll work for a few hundred miles on a globe, no more.
Kango 24. Measure the change in angle to Polaris as you move towards it. It drops 1 degree in the sky every 100 kilometers because of the shape of the Earth. It's a globe. Nice claim. But there's a lot more to it than that, Kango, and you're dead wrong. Thank you, though. Anyway,
How do you think this
I do have a
works,
question.
Paige?
I do have a question for you guys. Did
I did
you
go
guys
through
get
with-
some research about like neurolinguistic programming or keywords or psychology that said make sure you say that they don't understand and you don't understand, and if you understood all the time, and that would be impactful in your little game you play here? Or is that just something that kind of was spawned from person to person like a fucking plague?
No, the problem arises is when you tell someone they don't understand and you try to explain and they continue to interrupt, they're only confirming that they don't understand and they can't.
No.
It's worse when they understand, explain it to
That's
you,
just stupid.
and then you say they don't understand.
It's
While you're
it's
listening.
worse when they explain it to you and you just
You
refuse to
spewing
even go and
retardation
look.
and saying that people don't understand
That's
doesn't mean they're going to
fucking
want to sit there and
gaslighting.
listen to
You're
more
a fucking
retardation.
psychopath.
Like, of course they're not going to want to listen to that garbage. That doesn't
it's
mean
just
that they don't understand. It means they don't want to hear any more of your bull crap. That's all.
We go through the trouble of explaining the problems we found and demonstrating them and
You
explaining
haven't
to it.
you haven't found any problems. That's a problem in your judgment.
I explained the problem with the sextant. You just didn't want to hear it.
No, you said there was a video
Yes,
for someone
I
else
have.
to
You
explain
just-
it. Paige, can you explain it? Can you
You're
articulate it?
drawing an angle. I did before. Remember we went through it before when I
You
first brought
provided
it up.
explanation earlier,
Yeah,
a while ago.
Maybe I wasn't
A
here. That's
straight
fine.
line out to the address of that star will be different to a curved line out to that star. You need
We're
to
not
be at a
talking-
90-degree angle and straight under that
Shut
star.
up, B-Brick.
See, you asked me to
But we're not
explain,
talking
and then you
about
talk
directly
all
underneath
over me.
You
Yeah, I
keep
know.
getting it. And we're not talking about directly under the star. All we're worried about is the angle above the horizon.
2 straight lines.
So, yeah, one line to the
You
star,
don't
one line to the
have
horizon.
one.
One
You
line
just
star,
what's the answer?
one line to the star. What's wrong with that?
The star will be in the angle to that star will be different if the line from your feet out is curved, not straight.
Right, that's what I was saying the whole time. Can you correct Travis when he was arguing with me about that? Can you let him know that you would get different values depending on if the thing that you're on is curved or not?
Well, we're getting echo from somebody.
I already acknowledged you only get that difference of angle when you impose your curve.
No. It's a basic principle. It's not. I'm not invoking a spherical Earth because you will get different angles. What I'm saying is, if the Earth is curved, you will get particular angles at particular locations. If the Earth is flat, see,
You
more
have to
interruption.
prove
More
there's a
interruption.
curve.
Hold on. And if the Earth is flat,
What
if the Earth
angle
is
do
flat,
you
you'll
think
get.
you're talking
Hold
about?
on, let him finish, guys. Just let's
It's just
just
a basic principle.
let
No
him
one
finish.
should disagree with. If the Earth is curved, you're going to get particular values at a particular location for your angular view. And if you're on a flat Earth, you're going to get different particular values at particular locations. We should be able to agree to that basis.
With everything else held
Get
constant,
it, okay?
bio.
I fucking get what you said, okay? Now look.
Right, same location, just
Okay,
different
hold on.
shaped Earth. Yeah.
No. You don't do a fucking shape of the Earth. You take the angles from where you're at. You're not going to get different values until, like I said 15 minutes ago, you impose your curve after you take the fucking angle.
Because those angles match as you move away from that specific
Both
target
match,
in
you
the sky.
dick.
Yes, they do.
Okay, look.
That matches a
B-ball,
sphere
look.
because you made it.
Will always match your latitude. Always.
So what?
A fucking projection. Listen to me.
The
Listen to
globe
me.
will always match the globe, no matter
Yeah,
what
right.
you do.
Right. What the fuck? Okay, B-ball, look. Stop. Just stop. You go to the beach, wherever you are, in Waikiki, whatever, okay? All you do is take a compass sextant measurement of the sky. That's it. And then you swap places with me. And you take the measurement where I was, and I go to where you were. Guess what we're going to have exactly the same? Our sextants measurements are going to be exactly the same.
So one thing that I find very interesting, being a sailor, listening to these conversations.
I'm sorry. Let my point please either be disputed or ignored or hand wave dismissed, okay? Because
Yeah. Let me explain. Let me get to
no. B-ball. I was addressing B-ball. Do you understand what I'm saying?
At best.
Do you understand what I'm saying, B-ball?
B-ball.
I'll take that as a yes. He understands.
Beeble doesn't even understand what he's saying. Come on.
I'm sure he didn't, because I didn't, and I'm sure nobody else here does.
Shut up, Chikey.
So what did he
I don't
say?
know
What exactly
what is
did he say?
significant? Yeah, what's the
Okay.
significance of what you said, Travis?
I'm just going to repeat myself. So you want me to repeat myself?
No, I know what you said, but when you said we get the same result, you mean the same result the other got, or the same result you had before when you
Okay,
were
listen.
at
Okay,
your house? What are you talking about?
I'm just going to repeat myself now for the third time.
You each have the same measurement.
If I get a sextant and I take a measurement to Venus, whatever, where in my location, and then B-ball
And then I take a measurement to Venus.
Yeah.
And then we swap.
Wait,
Yeah.
let him talk.
Yeah. Okay. Whoever it is, you, me, B-ball, or whatever, we're just going to take measurements of the sky from our location. And then we're each going to go to each other's location and repeat the same measurement to the same measurement that, I'm going to measure what you measured. You're going to measure what I measured. Paige is going to measure what both of us measured. We're all going to end up with the same degree of sextant measurements.
From a zenith, Chikey, from a zenith.
Yeah, so what's the point?
So it's only the story
It's got
that goes
nothing to
along
do-
with it.
It's got nothing to do with what you think you call the shape of the Earth.
So because two people can repeat the same measurement, therefore we can't make any conclusion about the shape. Is
What
that the
fucking
logic that you're
shape?
providing right now?
What?
Of course we
What
would have the same
fucking
measurements.
shape?
Of course we would come to the same measurements. Of course,
Same measurements
whether we
of the
assume one
sky,
or another,
or-
you're going to come to the same measurements. What substance are you providing with your explanation, Travis?
He's
There was
saying
nothing-
they're not doing
How are
anything
you
to the
jumping
ground.
from measurements of the sky to shape of the Earth? I think that's his point. Is that you're going to get the same measurements in both
No, you're not.
places by both people, and
Right.
somehow you're taking those measurements visually from the sky and saying so equals sphere Earth.
Right, you need multiple observations. As Paige said earlier, the values that you get are going to be different whether it's flat or sphere. So what you do is you get multiple.
I think you're thinking of the wrong angle.
me,
I'm
man.
talking about the angle. When you look out, when you reach the address of the star, that is then a 90-degree angle straight up. If you're on a curved surface, that is now not 90 degrees from you. It'll be,
That's zenith, of course it
more.
is. So anyways,
It'll be tilted away.
before I was rudely interrupted, of course you would get different values on a sphere or flat
Oh,
Earth.
go
What you do is you
change
add
your nasty
multiple observers at the same time. So you add these distances. Therefore, you can come to a conclusion of the shape of the Earth that you're on because you have both angles and distances.
Welcome to Donkey Talk with Biodual and
Hold
Chikey.
on.
Oh, I'm sorry
And you
that I'm
can say
introducing
they're
math
all
into
on a
this.
flat
Sorry.
plane, biofuel. You can say
here
all
are
those
a
measurements
couple-
and angles are on a flat plane.
No, here's a
It's
couple
just-
of things you don't understand about using a sextant.
Oh,
First
careful,
of all,
you're banned.
Yep, that's fine.
Y'all clearly
First
do
of all,
not
you
understand
don't.
what we're even telling you.
You
and
don't.
you're-
All right. Since he wanted to go ahead and invoke our misunderstanding, we'll read the super chat while he's talking. Rob Keen, $5. Why do globe defenders and anti-flat earthers think the surface of Earth is two-dimensional? I don't think anybody thinks it's two-dimensional, do they? I mean, that would be a weird-ass thing to think. But thank you, Rob. Appreciate it, man.
So
have
you were the one
literally
who
not understood what
not
I've
her.
said.
You had the lack of
To
understanding.
me, you guys are arrogant.
There's no geographical position on Earth. That didn't make any sense.
What is the point of acknowledging that
What the
things in the
fuck?
sky have a zenith to the Earth?
How
You're
are
not
you
adding
using your
anything to the
sextant if you are
conversation,
not
Paige.
giving that star an address on Earth? What the
Paige,
hell are you
all
doing with
on a
your
flat
sextant?
Earth, on a flat Earth and a spherical
Bio,
Earth,
shut
all
up.
things in the sky,
Shut
all
up,
things
I'm
in
not
the sky will have
asking
a
you.
zenith.
So
Correct.
the other,
This other guy made a claim.
right? The
Holy
other thing that I find funny, being a sailor listening to this conversation, no one ever mentions time.
Dude, you're
Without
not
an
a sailor. You're a deckhand, bro. You done proven it. Okay.
Without
you don't understand
a-
a straight line. If you don't understand what a straight line angle is,
Dude,
Without
the
the
stars
time,
move. So
the
yes, of course,
observation
every
is
minute of the
useless.
day, every
No
minute of the
one
night, they're going to
mentions
be
that
different.
because no one's ever made the observation. It's one
you
of
say
the
straight line
clear
angle, bro?
hallmarks.
Can you say
Maybe
straight line
not.
angle?
Maybe not.
Dude, can't you understand that if you draw a straight line out from your feet to underneath wherever a star is, if you're on a curved
not about
surface, the line that you then draw up to the star is going to be angled outwards, whereas on a flat plane, it will be 90 degrees straight up.
It's not about.
See, you had to talk all through me, Bio. When even though you said before I
That wasn't
rudely
me, that was
interrupted you,
Beeble.
you talked
That was
all over
Beeble,
me.
not me.
Well, how about you
I'm
pull up
sorry.
your side then?
All right.
You had it so wrong.
Hold on,
So wrong.
B-Ball.
We're not-
Hey, shut
we're not
the fuck up
concerned
for a
with
minute, B-Ball.
underneath the
Shut up for
stars.
a minute. Autodidacts. Repeat
that's
what you
the way
said,
it's
Paige.
done.
Repeat what you said.
Whether you
No, Paige, you're
Holy
wrong.
fuck! Never mind.
Underneath the star in the distance.
Never mind.
No, it is.
We're not concerned with
Howard,
what's
for God's sake, mate, go and have a look at the video, 10th man. The presentation he's done.
Slow down.
wrong.
All
So
right.
you're going to remain ignorant
That
too. Well
was
done.
not right once in his life.
Guys,
Come on.
B-Ball, Paige. I muted you. Shut the fuck up. And just listen to each other. Let the other person have their answer. Paige, please repeat what you had said. And then B-Ball, respond. Go ahead, Paige.
Just insanity, man. I can't. We have to explain straight line angles over and over. It's like, are you kidding me? And then they keep trying to switch it to the zenith of what's over her head. That's not what she's talking about. Are you kidding me?
Why'd she bring that up then?
I honestly
What was the
don't know
specific
what
reason
she's
for
talking
that,
about, to be honest with you, Brian. I
See
don't
if you're
understand what
gonna
she's saying. I haven't watched the video yet. Hold on. I'm in the middle of
Talking
saying
about the
something.
zenith of the star, you dick.
Yeah, I know.
God
To the surface
damn.
of the Earth, whether it's a sphere or flat, that all celestial
Well,
bodies
if
will have a
quarter of the
zenith
way
to
around the
the surface of
globe,
the
do you think
Earth. Why?
Oh, fuck. I'm a fucking asshole. My mic's been muted.
Because she was explaining the function of with a sextant.
Hey, okay.
That's not how sextants work, though.
Guys,
Okay,
can we
hold on,
back
hold
up
on.
a little bit? Hold on, Travis. Hold on, Travis. Can we back up a little bit here? Paige, can you, without the rest of us interrupting, tell us what in this 10th man video you're talking about angles? Because I honestly haven't watched it, and I don't understand what you're saying.
Okay. Right. So if you draw it on a ball, you've got the little man on the top, and you draw a straight line out from your feet to however far. So if the star's 3,000 miles away, you've got to draw the line all the way out to exactly under where the star is positioned on Earth, right?
Okay.
So when they do that, they get a 90-degree angle from the end of that line up to the star. That's how they know they're directly below the star.
No.
Don't interrupt her. God damn it. Just let her get it out. Go ahead.
But on a curved surface, if you were to draw that line curving down and away 8 inches per mile squared, the star is now not able to be at a 90-degree angle anymore.
Right, and the circles would they would cross each other at
Brian.
different points. In other words,
Yeah,
okay,
no, go ahead. You go ahead. You might add something I haven't thought of. Go ahead.
yeah, the circles of convergence, the way that you line them up, the points of convergence of the circles would not even be the same fucking angle, much less the same position. If they don't understand this, it's donkey talk.
Different
dude. We're talking
3D,
fucking
different in the 3D axis of it all. Like the star, the angle in the star where the star is positioned on a flat plane compared to a ball would put it in a completely different place in 3D space. Like,
so what they do in reality is they
As
draw
a
the
sailor,
circles
hold on.
the flat map. They draw the
Guys.
circles on the flat map, and then they converge them depending on the stars that you're checking out. Okay, the zenith of the star, not the person of the star, and where they converge. Okay, is what they go by in 3 dimensions. Think about that in 3 dimensions on a ball. They would converge
That's not
in
true.
completely different spots. It does not work. You have to do it on a flat map. There are flat lines.
Brian, you're looking at the wrong angle.
Hold on a minute.
You're looking at the wrong angle.
Go, Brian, or B-Ball.
Brian,
Respond. You
can
had
you
a
make a
problem
straight
before. You
line?
were arguing. You respond now.
All right, Brian, can you make a straight line with an auto level from your eyes to the horizon?
Yes.
If you put the crosshairs right on the horizon, is that a straight line?
Yeah, so you understand why spherical excess doesn't work, right?
Okay, hold on.
Now, what you just said.
Oh, hold on. Wait. So we made a straight line from the auto level from your eye to the horizon. Now the star is above the horizon, right? Now all we're concerned with is the angle from the horizon, where the crosshairs are touching the horizon, to the star. That's it.
So what? Okay,
That's
so
a
what
90-degree
orientation
angle,
do you
you
draw
dick.
the
It has
circle?
nothing to do with it. It has nothing to do with a
No,
90-degree
it's not.
angle below the star. Below the star. It has nothing to do
So
with that.
what orientation do you draw the circle
I'm not
around
saying
that
you
star?
use that
What
to
are you
measure
talking about?
anything. I'm saying that's just a thing that ends up happening. That is
Okay.
what happens.
Well,
You have
on
a
your
90 degrees.
Let me ask B-Ball a question.
No,
B-Ball, let me
it
ask,
has nothing
let me
to do
ask
with.
you a
It
question.
has nothing to do with 90-degree angle.
Let
Nothing.
me ask you a question. Okay? After you've taken the angle out to the horizon, which is straight in front of you, and you found a star, let's say that it's the star Sirius, and it is above the horizon, what degree above the horizon is that star?
It depends on what star you're looking at, and it depends on your latitude. If you're at 30 degrees latitude, Polaris is going to be 30 degrees above the
you
horizon.
don't need a latitude. No, you don't need a latitude. Let me ask you a question. Is the star directly above the horizon?
The distance to the star is irrelevant.
I didn't say what the distance was. I said when you're looking at the
Because obviously,
horizon.
if the star was right above the horizon, that means the star would be what, 3 miles away? Come on, man.
Again, if you're thinking about simply 2 dimensions, it's straight above the horizon.
No,
You
it's
don't
not.
know.
We're not concerned with the distance. That's why. This is why you don't know our model.
I
You don't know the model.
didn't say distance.
Don't know the model, so just leave it alone, man.
I didn't say
Understand
distance.
before you have an argument.
B-Ball, you're flaking.
B-Ball,
You gotta
I
have a
did
flat
not.
piece of paper to
I did-
use a sextant. You gotta chart it on a flat fucking piece of paper. You fucking retard.
I would like to hear from Kool-Aid.
Right. So you don't chart anything. You don't draw it. The only angle I care about is the angle my sextant's reading.
So all you're doing is looking for latitude. You don't need the fucking sextant for that.
Right. So I care about the angle that my sextant's reading and the time that it reads it. That's it. I don't care about any other angles. I don't give a shit how far away they are.
It doesn't matter whether you care about it or not. That's what happens. You get a 90-degree angle from the position on the ground underneath the star to your feet. That's just what happens because you have to have a flat plane under each one of those stars. Howard, no, I'm not. You haven't even gone and looked at it.
Yes, I have.
So what have I said that's wrong?
10th man is completely wrong in his description on how.
Even on your model, Howard, you would claim that line was a 90-degree turn.
No,
You'd just say
90 degrees.
You'd just
90
say that
degrees
star
has
was
nothing to
now
do.
vertical.
Nope.
Yes,
90
you
degrees
would.
has nothing to do with the
Here's
Seems
something
like this
simple,
might come
Kool-Aid.
back to them thinking that triangles have curved lines.
Kool-Aid,
Yeah.
you have used a sextant. You understand how it works,
Yes.
Kool-Aid?
Yes.
Awesome.
Many
Do you
times.
care about a 90-degree angle?
Not at all.
Ah,
It
well, there we
doesn't
go.
matter whether he cares about it or not. This is what it gives you.
Hey,
So-
Paige.
No, it doesn't.
Paige.
No, because
listen.
the
Let me step in
only
here.
angle I care about is the one that is red on my sextant.
Gotcha.
That's the
So,
only angle I
Paige,
care about.
Paige, I don't understand the contradiction.
Let me explain,
I'm
Brandon.
not seeing
Brandon,
it. No, just
can't
somebody
have
make it.
the
Can you see my
angle
screen?
on
Can you see my screen?
Saw the diagram,
Brandon,
Brandon.
the angle on
Like,
his sextant to close that triangle requires a line from the top of the star down to the bottom of his
But
angle.
even if
You
they did
understand
that, they could still say, "Here's a zenith," and mark it from zenith down to 90 degrees, down to the horizon. Right? So I'm
Right,
trying
90
to I'm
degrees.
trying to
Yeah,
figure out what the
if you
contradiction is,
allow
because
them
here
to have a
Zenith.
curved line on the bottom of their triangle.
But they don't need a curved line. They can do it from the
They're
top,
standing
from
on a curved
zenith.
surface.
I don't
Then
see
they're
the contradiction.
keeping
That's
their
the point,
measurement.
I
do
think,
it from your
Brandon.
feet to
that
the
seems to be
stars,
the whole
Brandon.
thing is that, yeah, they can say they're making a straight line from themselves out. That's the problem. Is they say, basically what they say is, if we pretend we're on a flat surface out to the star, everything works fine.
Then
Well,
it
great,
works.
buddy.
Yep.
But you
No,
don't
no.
that. You say you're on a
That's
All right,
exactly
listen,
what
I
they do.
understand that. And I said earlier, it's funny because they always
Do you want
have
me
the
to
guy
find the
standing
diagram,
on this
Brent?
flat plane, right? But they don't even need that. That really they don't, because all they have is a zenith. They could just say, okay, when it's up here, and mark it off zenith with basically they do, and they stop it at 0 and 180, which it is happens to be the horizon, and then they tell us that the horizon isn't what it would be on a flat surface. It's actually the circle of sight around us that we can't see past because it's hidden behind a curve, which is ridiculous. But I don't see the contradiction here.
There's a
See
reason
that,
they don't
you
chart
see
it
the
on a
line that
globe.
guy is standing on? They say that that's curved around the Earth, but they're still going to attempt to use it as if it's not curved.
I know that's why
the
they put
problem.
the stars so far out here, because if you make it at this angle, right? If you have it at this angle, it's like right above the horizon. They're all fucked up, dude. They have it at the near the horizon. You can put it out here to infinity.
Where the argument's coming in.
You can put it out into infinity, and you'll have the entire circle covered. But maybe I need to watch the video so I understand it. But I'm not hearing a blatant contradiction yet. I'm not saying it's not there, but it's not coming
that
across.
is the contradiction, is that they claim that they're on the curved surface, but they get to pretend that they're on a flat one for their navigation and then claim that it works on a ball. That's the contradiction.
No, because our navigation goes off, as Brandon's perfectly got on his screen, it goes off into outer space, and who cares where it ends up?
Well, I said what I said.
Yeah, I get where you guys are coming from, but I don't think there's much here as far as falsification. Personally,
I found
it
a
doesn't
video
falsify
for
anything.
you. I don't know a timestamp yet, but I'll throw the video that says it's got the sextant.
No, I want to ask.
And I should be able to just scroll through and find.
There's
Once
a
you see the diagram, once you understand it in a 3D, if you think about it in a 3D way, you can understand how the star is going to be in a completely different position. Just one.
Hey, Brandon, move the person in both of those models to the right, like 2 shoulder lengths, but orient the globe person properly with the feet, and then you can see how the angle would change.
you have to see how these stars are set at a certain distance. So sure, yeah, we'll assume that this star is right here, and we can assume your model of optics, and then we'll falsify your fake ass model of flat Earth. What good is that going to do us, BioDual?
No, what I'm saying is the person on top of each model, move them to the right 2 shoulder lengths, but orient the globe person with the feet on the Earth, and then do that red line angle.
like this.
Right. And now you're not going to have a straight line. Now you're going to have a different angle. Despite
Wow.
both of them moving to the same location on each model, you're going to have a different angle. And that's how you
Okay.
differentiate. That's
I'll
how you
repeat myself
essentially
again.
determine the-
I'll repeat myself again. Assuming the
lower that
distances that
flat
you
Earth,
assume and
to
the
the right.
fucked up globe optics model that you have, sure, you can falsify a piece of shit flat Earth model that you have, which is no use to anybody.
Wait,
I want to see them
you have
plot.
a
I want to see
different
them plot
kind
with a
of
sextant
flat
on a globe.
Earth?
Chikey,
What
why do
kind
you
of-
think they don't plot with a sextant on a globe? Why is that? Because it don't fucking work. Try. Go outside with a sextant.
What-
Just make one. Make a sextant. Just get a
why
protractor
did you
and
make
try and plot. It might work right up close, but when you get off the distance, you can't plot that shit on a fucking globe, dude.
why did they make sextants at all?
Chucky, what are you talking about? Why did you just ask
Hey,
why they make
I don't know. It
sextants?
said sextants
Listen,
don't work.
listen,
They don't work.
They make them because the
What-
Earth is flat and the stars don't move.
To
Yeah,
measure angles from the horizon. That's all
Yeah,
it is. It's like a
they-
ruler.
they used them because out on the ocean you don't have landmarks. You have the stars. So you measure the angles of the stars, you map it out on the charts, and those things don't move.
Yeah, because on ship it's hard to keep things level. So
What?
Just real
it's
quick,
hard to
Brandon,
keep
you'll have to
things
change the name
level
of
on
the
a
line.
ship. The ideal would be to have something like auto level, that it's level and to measure from this level. But since it's a bit difficult to do on sea, especially when it's storming, then
They don't
the
do
next
the
best
sextants
thing
in the
is the
storm.
horizon.
They don't do the sextant in the storms. You can't see shit.
Like I said, donkey talk with Biodual and Chikey. They talk about
can't
during
see-
storms, just clouds.
You can't see this. You can't see the horizon in a storm, and you can't see the stars. What the fuck are you talking about?
Well, there's wave in the ocean most of the time.
Yeah, guys, what I find interesting is in these conversations, nobody ever mentions volcanoes. Okay? Nobody ever mentions the volcanoes.
Or mermaids.
We get
Or the
unicorns every
fucking
now and then.
Teletubbies.
We love unicorns, Paige. Absolutely.
Anyway, we got
And I
about
suppose
10.
the bottom line is they assume a flat plane when they do this. Like, that's the bottom line. You know, these guys can think that, you know, then they can curve it around a ball all they want. But the fact is they will draw flat planes, flat circular planes, cut a bit off the ball, flatten it out, and pretend that's what they're working
Right,
on.
that's what I meant. They can plot it on a flat graph, then wrap it, okay, and make it work on a globe. I'm not saying they couldn't do that, but let's see them try and plot it on a globe. They don't do that. They plot it on flat maps, man. I don't see why
Think
they
Oak-
even argue that.
I think Oakley did something with this flat circle thing on the globe a week or two ago. Yeah, I remember seeing this.
He done it with Rumpus.
Yeah, I just chucked it in.
Brandon, what were you going to say?
Oh no, it's almost 8 o'clock. I was gonna end the show and see if anybody wanted to have any final
end the
thoughts or say anything
Don't end
before
the
I
show.
shut down the.
Don't end the show yet.
Can I
Don't end the
summarize?
show. I sent you a message last week.
Yeah,
You got
yeah,
like-
it's all yours, Glean. Let's give it that passage to Glean for a minute. Let him summarize, man.
Yeah, go ahead, Gleam.
Yeah, I think what it is with the Sexton talk, it was more the globe earthers. You got a horizon basically, and what the flat earthers are saying is, yeah, you measure that horizon, and then you apply the globe earth maths. And Rumpus' exact words, I'll quote Rumpus. I'm sure these were his exact words on Oakley's show. Is we take the measurement, and then we manipulate the angle to fit a globe. Okay, and then what they're basically saying is once they've got this angle which fits a globe, they're then coming to you with the resolved maths saying, ha, look, it fits a globe. when what Page is saying and the flat earthers are
Right.
saying
So
is,
they're using
no, you
longitude
start.
or latitude to prove longitude or latitude.
Well, you had to start with the planar model to get your angles first, and then you had to change that original angle that you measured
Exactly.
to fit the globe.
They start with my
Ask
model,
Rumpus.
and
Ask
then
Rumpus. He
What
proved
does
it. He
Rumpus?
showed
We
it.
know it's 1 degree per 69 miles. We know it. Don't need to manipulate anything.
60 nautical miles, Chucky. You corrected me earlier.
Well, the same thing. Now
That's
you
in the
can't
sky,
fit that
Shikey.
on
That's in
flat
the
Earth.
sky.
Doesn't work.
That
Doesn't
is
work
in
on
the
flat Earth.
sky, Shikey. That's in the
Yeah,
sky.
we know. It's in the
All right.
sky.
Shikey, tell me.
Thank you to the panel.
No! Don't
Thank
end
you.
the show. Wait,
Well, you got something, Bob?
Brandon. I sent you a message last week.
Oh, you did.
Okay?
Okay.
And I told you I had something I wanted to go. Can we go just a little bit longer on the show so I can explain something? Somebody brought something up the other night, like last week, before you stopped having shows forever or whatever. And it wasn't on the show. It was like we were just hanging out in the chat. And they got something wrong. They got something very wrong. I don't know if they did it on purpose or if they were trying to trick people, but they unfortunately convinced some people that they had gotten it right. And I don't know if it's something that's going to be used coming up here to attempt to trick people, but I want to go over it. It shouldn't take very long. I want to go over it so that people are prepared if it starts getting used, that they can basically dismiss it because it's nonsense. It's stupidity. Okay.
Yeah.
So,
go ahead. We can stay on longer. Yeah. Do it.
Great. Cool. I'm gonna share my screen and then I'll ask you some questions, Brent. I'll interact with you so that we can get through this. Okay.
Okay.
All right.
I mean,
so I'm sharing-
everyone shut the fuck up.
Let me know when you can see my screen.
Got it.
Okay. And can you read that sentence?
Gerbils do not exist.
Okay. Fantastic. Now, is that sentence, that phrase, gerbils do not exist, is that a positive statement or a negative statement?
A positive statement.
No.
No?
It is not.
It's
That is
a negative statement.
It says do, which would be positive, and then it says not, which is negative, and there's no other language in here that would further modify the phrase. Therefore, it is a negative statement.
Okay. See, I would have thought it was a positive because it's a claim.
Right. So that we're going to get into this. Okay? That is a negative statement. You can rewrite this as, let's see here. Gerbils are not.
You should use something that really doesn't exist and say it doesn't exist.
No. Just I'm using this so that it's very simple to understand. Okay. There's a reason I picked gerbils. We'll get into it. Just hold on. Okay. Oh, whoops. Did not equal gerbils. Equals negative. Okay. Okay. Are not in existence. Yeah. Okay. So I'm going to type another one. Let's do this. Blue gerbils do not exist. Okay. So now, if this is a negative statement, which I don't think anyone actually disagrees on, if you look at the way the word is set up, gerbils do not exist. You're dismissing the existence of gerbils. Therefore, it's negative. You're saying I do not believe the gerbils exist by saying gerbils do not exist. Okay. So I mean, here I can add that. I do not believe gerbils exist. Okay. So if you see this, there's still only one negative word modifying this phrase. I do not believe gerbils positive exist. Okay. So it's still negative. These are all negative statements. Okay.
Okay.
So if these are all negative statements, you would agree then that blue gerbils do not exist is still a negative statement, correct?
I would think so, yeah.
Okay. Negative. And let's go ahead and do this. Let's go ahead and put parentheses around so we understand how this is broken up a little bit better. Okay. So this gives you an idea of how these are separated.
Okay, so each grammatical kind of unit are you're putting parentheses around. Is that what you're doing?
Right. So and this is just to break them up to show you the structure of the statement.
Okay.
Okay. So you can see because the point I'm going to make, like I said, he either tricked people or confused them into actually thinking that he was correct when he wasn't.
Interesting. Who was it, or is that a surprise?
Well, it's not important right now. We can discuss who it was later. And I don't, like I
Okay.
said, I don't know if he's trying to do it on purpose or not. So I don't want to like throw him under the bus and say he was being a deceiver or something. Like I don't know if he did it on
Gotcha.
purpose or if he might have legitimately not understood what he was saying. Okay, so
All right.
in this case, look what happens with this statement.
All right.
Now, any disagreements on how I have set up these parentheses?
I guess the only difference I see between the three that stands out to me is that you've grouped blue gerbils together as
Okay.
as one
So
thing. Yeah.
I'll explain that. Gerbils in this sentence, gerbils do not exist. Gerbils is the subject, correct?
Yep.
Okay. In the second statement, gerbils are not in existence. Oh, I didn't put existence. I put existent. Gerbils are the subject in this phrase, correct?
Yep.
Okay. And in this one, I do not believe gerbils exist. Gerbils are the subject in the statement, correct?
No, the subject is I in that statement, isn't it?
Okay, yes, you could argue that there are two subjects, but as far as making the statement that we're trying to make with what we're saying here, what we're talking about is gerbils. We aren't talking about I's existence. We're talking about
Okay.
the gerbils' existence or
All right.
non-existence, correct?
It's been a long time since I've studied formal grammar anyway, so I might not know what I'm talking about. But yeah, all right, I'll go with it. Gerbils.
Okay.
They all look good.
And so in this statement here, blue gerbils is the subject, do not exist, and that's a negative, right?
Yep.
Okay. So let me throw this at you.
Hairless gerbils now.
Is this a positive or negative statement?
Hairless gerbils do not exist. Negative.
Exactly. And that is not what this person was saying. I'll explain to you what he was saying. He was taking this right here, basically, and we weren't using this phrase. We were using something else entirely. But he was essentially, his claim was, because of this right here, less, hairless, right here, he was saying that this whole statement becomes a double negative because it's hairless gerbils do not exist. Okay.
All right. So he thought that the fact that it said hairless, like they're without hair, was another negative.
Right. Exactly. And I tried to explain to him that that's not how that works. See, a core feature of a double negative is that when you change the negative part, if you change one of the negatives, it should become the opposite statement, right? So gerbils do not exist. You should be able to change either of those negatives into a positive and get the opposite statement of gerbils do exist. So
Right.
gerbils do not exist equals they do exist, right? So the opposite statement is they do not exist. So gerbils do change the second negative, not exist, or change the first negative, or gerbils do not do exist, change the second negative. Either way, it becomes gerbils do not exist, and I'll type that out. Okay.
Okay.
So gerbils do not exist equals gerbils do exist.
Right.
Yeah, the two
Okay.
knots cancel each other out. Yeah.
Exactly. This is a double negative. So the actual statement is gerbils do exist. If you change either of the knots, it should become an opposite of gerbils do exist. Well, let's try that. Let's change the first one. Gerbils do not exist. This, we could change that. We can put in do instead of it,
You
or we
got
can
your
just leave it
full grown
out.
about
They
3
do
miles ahead of you. Little hail, old piece size hail down there too, about 5 miles ahead.
Someone's got an open mic.
Hot mic, Howard. Hot mic with the hail. Here we go.
Oh, sorry. I'm sorry.
No
Left
problem.
lane. Get over into the right lane.
Thanks for the update, Howard.
Gerbils do not exist. Gerbils do not exist. What is
Gerbil
that?
doo-doo does not exist.
Gerbils do not
Okay.
exist. Dude, yeah, okay.
So do we agree that this statement, this last statement here, gerbils do not exist, would equal gerbils do not exist, correct?
Yeah, that would be a negative as well, right? Yep.
Right. They do not exist. Okay. And we can change the other one. Gerbils do not exist.
Do not exist.
So by changing
It is getting
either of the
crazy.
negatives in the double negative, both times, both times you end up with the exact opposite statement of the original double negative.
You have contradicting verbs, though. Do, gerbils
That's
do,
not the point.
do not.
This isn't the
is
point of that.
contradiction
All
of
I'm
verbs.
pointing out is the modification of the phrase to be a positive or a negative statement. So this one here, gerbils do not exist, is the double negative, and it is equal to gerbils do exist. If you change the first one, gerbils do not exist, you get gerbils do not exist. If you change the second one, gerbils do not exist, you get the exact opposite statement, gerbils do not exist. Okay?
Okay.
So let's try it with the hairless. If we
my God.
change, I'm almost there. Okay.
This truly is a stupid waste of fucking time, in my opinion.
No, it's not a waste of time.
Just
I
let him
understand
finish.
that
We
you
came
would
this
think it's a waste
far.
of time because you
We're
don't
doing
want
this
people
because
to
of the
understand
Globers.
reality. I get that. But it's important for whenever people are making claims or not making claims to understand who has the burden of proof.
No,
If
Don't let him
we
distract
change
you.
hairless,
It's very important.
if we change hairless to hairful, gerbils do not exist. We've only changed one of the negative parts of this phrase. Have we made the exact opposite statement of hairless gerbils do not exist?
I
We have
prefer
not.
furry, but yeah.
We have changed
No.
the subject of the statement. We have not made the exact opposite of this statement. We've made an entirely separate new statement about something else entirely. Therefore, this cannot be a double negative.
The
Simply
hairless
because
part.
the gerbils was modified by hairless.
No, of
Yeah,
course
the
not.
hairless part is just an adjective describing the gerbil that doesn't exist.
Exactly.
Yeah.
So,
What are they teaching in school these days? Like,
okay,
So-
listen.
I thought this
now,
was.
you might catch it when I do this.
All right. You cannot have gerbils without hair.
That's another way to put hairless gerbils do not exist. A negative. Right?
It has a slightly different meaning, I think.
Isn't it
It
positive?
doesn't say
Isn't
why
it
I
kind of
can't
negative?
have gerbils without hair. It just says I can't have them. They could
Right.
still exist.
It doesn't give a reason. But someone saying hairless gerbils do not exist, and you saying you cannot have gerbils without hair is saying the same thing. Okay?
No,
We're not talking about hair as in,
no, you're
we're not talking
wrong.
about like a parent talking to a child
Oh,
No,
hold
you're
on,
wrong.
Bob.
you're not allowed to own.
Don't say
Just
he's
said that you
wrong.
can't have
No.
them. He
No,
can't
no,
have them.
no,
Doesn't mean
no,
they don't
no.
I
exist.
just took care of that.
No,
I just
Bob.
took care of that. I just
Bob.
took care of that. We're not talking about permission.
Right.
We're talking about existence, remember?
Yeah.
We're
Okay,
talking about
all right.
existence.
All right. So we're still talking about
You cannot
existence.
have
Got it.
gerbils without hair. That is the same as hairless gerbils do not exist.
I would agree then if that's the meaning of you cannot have, that they don't exist. Yeah.
And this, even though it says without hair just is equal to
Hairless.
hairless. Those
Yeah.
are the same. So when you make the statement, you cannot have gerbils without hair, this is all the same section, because the without hair is only modifying gerbils. It's not modifying the negativity or positivity of the statement. Only the not is. So you are making a negative statement here. I do not believe that gerbils without hair exist.
Yeah, you should
Right.
say gerbils without hair
Okay.
do not exist.
So when someone says gas pressure without a container
I want to add something if I get a chance.
does not exist,
Yeah.
they are not making a positive claim. This
That's a negative
is the
claim. yeah.
same as gerbils without hair. Gas pressure without a container does not, the only negative modifier, exist. You are denying the existence of a thing. You are not making a positive claim of something.
Let me just add something out of this. This is where they do the burden of proof reversal fallacy on us, right? Because whoever's
No,
making the
that's where you
positive
do it.
claim, whoever's
That's where
making the
you do
positive,
it.
somebody
No.
mute him, please. Whoever's
No,
making
because
the positive,
just because you said no does not exist.
Shut up,
Doesn't
Shike.
make it a negative claim.
whoever's making the claim of non-existence, the burden of proof is on the person that claims
Flat
existence.
Earth does not exist. Boom.
Negative claim.
That was funny. I'll give him that.
It's very funny, but the claim is
I don't need
curvature.
to. I don't need to prove
Claim is that-
anything. Flat Earth does not exist.
Globe doesn't
the
exist.
claim is
Boom.
Well,
The claim
right,
is that.
you're correct.
Hold on, guys. Hold on a second. Don't let Shaky ruin this, please. The claim is that curvature, there's Earth curve, right? We're saying no, that doesn't exist. Gas pressure without a container doesn't exist. All the burden of proofs is on you guys.
No, you
We
don't.
have no
it doesn't
burden.
This is
exist.
basically
No.
the argument that was brought up the other night. Was this person was making the claim that because the gas pressure without a container, he was saying that was a negative modifier for the phrase, and therefore this was a double negative, which turns it into a positive claim.
Oh,
and
that's a
that's
stretch.
absolutely not the case, as I showed with the gerbils. That's not the case. If you change the without a container to with a container, gas pressure with a container does not exist. See, you haven't changed the negativity of the statement. You haven't changed the actual statement to an opposite. You've changed it to an entirely separate conversation by changing the without a container, by changing the subject. You might as well have changed gas pressure without a container to hairless horses.
See, that's that slimy sleazeball shit. Who did this?
Exactly.
It
So
doesn't
if
matter.
somebody comes
No,
to
it
you
isn't,
with this
because this
argument
has no
that
this has no
gas
place
pressure
within science
cannot
and
exist
testing
without a
things.
container, if they come to
You
you
are
and say
making a
that is a
positive
double negative,
claim.
they are absolutely
You're
100%
making a positive
incorrect.
claim because
Shut
you're
up,
attributing,
It is
BioDuel.
not
you're
a positive
attributing
claim.
properties
Because
Shut
to
up,
something.
demonstrated
BioDuel.
it's not a positive claim. It is a
You're
negative
attributing properties to
statement.
something.
Shut
Claim
up,
of non-existence. It's a
BioDuel.
claim
It's
of
That's where-
non-existence, and
The
anyone
That's
claiming
where
that
it
it
breaks
does
down.
exist.
does not change the phrase. The phrase is positivity or negativity. That can be bluegrass gas pressure. That can be gas pressure that's orange, gas pressure that's hot, gas pressure. You can put any describer in there without a
Right,
container.
we've
Is
heard
a
it
Can you write
equivalent
it?
of
Can you
gas
write it to make
pressure.
it more
It
clear
cannot modify
without
the
being a compound
positivity
sentence?
or negativity of the statement.
Right. So Bob, you
Write it
are
in two sentences, and
positively
maybe they'll get it,
attributing
Bob.
Hold
you're
on, Aaron.
positively attributing a property to something. That's what you're
Shut
doing.
up.
It is
No, you're
a,
not.
it
Not
is
No,
a
you're not.
position.
You are not
It
No
is.
way. There is
You
no
are
way this
describing
guy is
on.
going to
one
try to argue
version of it.
against
You
what
are
Bob
Let's
saying
hear.
said.
Let's hear
this
it. Let's hear what he
version
says. Let's
does
just
not
hear him
exist.
out. We just went on. Bob just gave his
Brandon,
argument.
don't
Let's hear
do
what
this.
he says. Go ahead.
Oh my God.
It's a
I can
positive.
explain why he's
Let,
wrong.
let him
Go
smack
ahead.
himself in the
When he's
face.
done,
Let
I'll
him.
explain why he's wrong.
It's a
Go
positive
ahead.
attribution to. It's a property that you're attributing to gas. That's what you're doing. Even if
Okay.
you're saying no, a container is required, or no, no container would be no pressure. You're still attributing a property to gas.
Okay.
No,
okay.
no,
now,
no, 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 not a property to gas. It's
hold
not a property to gas. Let me just
Hold
say,
on.
it's a
This is
behavior,
Bob's
bro.
argument. Let Bob go. Go
Let
ahead,
me
Bob.
explain why his argument doesn't matter. Blue is a positive property that I gave to gerbils when I said blue gerbils do not exist. And it still does not change the positivity or negativity of the statement as a whole. It only modifies gerbils. And it's the same with out a container. Without a container modifies the gas pressure. And you can say I've given the subject a positive attribute, but it's the same as giving the gerbils the positive attribute of blue.
We'll make it
Blue
simpler.
gas pressure
only
doesn't
exists in a
exist.
container. Very
But
simple.
here's your downfall is that in order for your premise to work, gerbils can't exist. Therefore, when you attribute blue, hairless, these properties, they don't exist because you started with zero. You're essentially what you're doing
No, that's not
is
true.
in math.
That's not true at all.
In math, what
And
you're doing.
gerbils exist, just
Hold on,
not blue
what you're
ones.
doing.
That's not.
What you're doing.
That's just
Gerbils
retarded.
exist, just not hairless
What-
ones.
Gerbils do exist,
I mean,
but blue gerbils don't exist. I didn't need to rely on their non-existence whatsoever.
What you're doing,
How
what
about
you're,
letting him finish,
what you're
Bob?
doing is like in math, dividing by zero. But instead of
No,
saying
it's
zero,
not at all.
instead
It's
of
not at
saying
all.
zero, hold on. Instead of saying zero, you've attributed A to be 1 and B to be 1. So in your mathematical statement, you're saying A minus. You're dividing by A minus B. You could
No,
divide by
absolutely
A
not.
minus B.
You're
But
incorrect.
if you know that A minus B
More
equals
donkey
zero,
talk.
you have committed a
Fired.
mathematical fallacy because you can't divide by zero. That's
Everything
what
he
your line of
just
logic
said
is
is in
doing.
complete and utterly retardation and has nothing
More
to do
donkey
with the
talk.
statements
We're
that I've
fired.
made
No,
while
it
making
was
my
over
argument
your
here.
head,
He has
Bob.
in no way
No,
negated what
it-
I have said.
The problem is when you talk about
He's a damn
gerbils.
fucking donkey.
Yeah, if you talk about
Yeah, it was
gerbils,
just
they'll agree
utter
with it.
retardation what he just said.
Yeah, see, if you talk about gerbils,
It
they'll
was
agree with
perfectly
it. If
describing
you
what
talk
you
about
just
the
said.
Earth,
No,
they get
it
triggered.
was perfect retardation is what it was.
No, I'll say it again.
You
You
did
divided by
not
zero
you
in the
did not
beginning,
disprove
so
what I just
everything
said
that
in any way,
follows
shape, or form.
is
You
not
in no way
applicable.
contradicted what I said. You went on to something else that has nothing to do with
No.
what we're talking about
Then
and was
let's go
worse
to the
to the
beginning then.
conversation. It
Your
was
premise,
utter
your premise
retardation.
started with
Do you
gerbils
have a
don't
real
exist.
argument or
That's-
not?
All right, guys. Well, that's going downhill fast. Yeah, I'm not. Science works in mysterious ways. Says I'm not the one to rely on the pressure argument. I have take, but I can't do it in chat and need to talk with my hands. Yeah, yeah. It's not really my favorite either. It's just not my thing, not my area of interest. Some people are really convinced by that argument, but it's just not one of my arguments that I go to. But thank you everybody for watching the show. We will be back tomorrow, come hell or high water. Although not windstorms. Windstorms probably won't be back tomorrow. But thank you to everybody for watching tonight. Thank you to Rob Keane, The Science of Science, Kango24, for supporting the show via Super Chat. Thanks to everybody who listened. And thank you to the moderators in chat for taking care of business out there. Appreciate that. And we will see you tomorrow. Have a good night. Talk to you later.